All right, let's take a look at our practice test. We're told to solve each equation. And for the first problem, we're going to look at 1 over x squared plus 10x plus 25. This is going to be set equal to 1 over x plus 5. Then minus, we have 2 over x squared plus 10x plus 25. Now, the idea with this type of problem, we're solving an equation with rational expressions involved. So we borrow a trick from when we solve equations with fractions. We first figure out what is the LCD or least common denominator. We know how to do that. And then we would multiply both sides of the equation by that LCD to clear all the denominators. The problem that comes up is that in some cases, when you multiply both sides of an equation by either a variable or you could say a variable expression, you might get extraneous solutions. Okay, so extraneous solutions are solutions that work in the new equation that's formed, but they do not work in the original. So sometimes that'll happen, and basically you just need to check your domain. So does the result you get, or the solution for x, if you plug that back in, do you get a rational expression where you're dividing by 0? Okay, so that's what you're checking for. So looking at this guy, first off, I would just factor everything. So this x squared plus 10x plus 25, which occurs here and also here, that is a perfect square trinomial. So that can be factored into x plus 5 quantity squared. So let's write 1 over x plus 5 quantity squared. And this equals, you have 1 over x plus 5. And then minus, we have 2 over, again, we'll have that x plus 5 quantity squared. Now, in terms of the LCD, you would look at your denominators. So you have x plus 5 quantity squared, you have x plus 5, and then you have x plus 5 quantity squared. So it's the same factor involved, but again, you're going to go with the highest number of repeats between any of these guys. So here it's a 2, here it's a 1, and here it's a 2. So the highest number of repeats is a 2, or in other words, our LCD would be the quantity x plus 5 being squared. So I'm going to multiply both sides of the equation by that LCD, and that will clear all of my denominators. So let's write this real small so we can fit it. I'll just say that we have x plus 5 quantity squared multiplied by 1 over this quantity x plus 5 being squared. Then this equals, we're going to have x plus 5 quantity squared times 1 over x plus 5. And you could wrap this in parentheses if you want, just for clarity. You don't have to, though. It's up to you. Then minus, you'll have 2 over. You have this x plus 5 quantity squared. And then this is times your x plus 5 quantity squared. Okay, so let's go through and cancel some things. So this would cancel with this. And then basically one of these, let me put a 1 there, would cancel with this. And then this would cancel with this. So I'm just going to take what I have. So it's going to be this, and then it's going to be this times this, and then I'm going to have this. Okay, so whenever you do this and you have a lot of canceling, you really have to pay attention to what's left. Sometimes you can skip something and get the wrong answer. So over here it's just a 1, and this is equal to, over here it's x plus 5. Remember, we canceled this out. Now there's a 1. So it's just x plus 5, and this is multiplied by 1. So anything times 1 is itself. So this is just x plus 5. Then over here we have a minus and then just a 2. Okay, so we'll just solve this equation real quick, and then we'll come back up and check. So let's write 1 is equal to x, and then 5 minus 2 is 3, so plus 3 there. And then to solve this, let's just subtract 3 away from each side, cancel that away. So this would be negative 2 is equal to x, or I would flip it around because I like my variable on the left. So I'll say x is equal to negative 2. Okay, so coming back, you want to check to make sure, first and foremost, that you don't have a domain violation. So in other words, what is the domain when we consider this guy? When you think about all your denominators, you would set each one of them equal to 0 and solve. Now in this case, you have a perfect square trinomial that factored into a binomial squared. So this x plus 5, you would set that equal to 0. You would solve that. You get x is equal to negative 5. So here for the domain, let me write this off to the side so nobody's confused. We'll put that the domain is going to be the set of all x such that x is not equal to negative 5. And I think you can see that if you plugged in a negative 5 here, negative 5 plus 5 is 0, 0 squared is 0. So you'd be dividing by 0. Here, negative 5 plus 5 is 0. Here, negative 5 plus 5 again is 0, and 0 squared is 0. So that's our domain, the set of all x such that x is not equal to negative 5. Now, if you're on a timed exam, I would just make sure that this guy right here, this x equals negative 2, does not violate the domain, right? So in this case, it does not. So you would move on with your test and maybe come back later and check for the simple mistakes that we often make when we're solving equations. I'm just going to go through, since we don't have a time limit here, and plug in, show you that the left and the right sides are equal. You can always skip this part if you don't need it. So I would plug in a negative 2 here, and then also here, and then also here. So over here, negative 2 plus 5 is 3. So we'd have 1 over 3 squared, which is basically 1/9. So let's just erase this and put 1/9. Over here, negative 2 plus 5 is going to be 3. So let's put 1/3 there. Over here, negative 2 plus 5 is 3. 3 squared is 9. So this is 2/9 here. So you would need to get a common denominator. You'd multiply this by 3 over 3. So this would be 3/9. So 3/9. And then minus 2/9. So 3 minus 2 would be 1 over the common denominator of 9. So we can see that we get the same value of 1/9 on the left as we get on the right. So this is a valid solution, right? It does not violate the domain, and the left and the right sides are equal. All right, let's take a look at problem number 2 now. So we have 1 over x plus 1 is equal to 5 over x plus 1 plus x plus 7 over x squared plus x. Okay, so I'm just going to rewrite this. So 1 over your x plus 1 is equal to 5 over your x plus 1. And then plus, I'm going to have this x plus 7. I'm going to factor this denominator so I can pull out an x. And that's going to give me the quantity x plus 1. So when I'm finding the LCD, remember, we're going to think about each different denominator. So this one's x plus 1. This one's x plus 1. And this one has an x plus 1. So that's common to everything. And there's only one that occurs each time. So that's going to go in. Then I have this x here that's only going to be for this one. But again, it's got to go in. Okay, so I'm going to put my LCD as this guy right here. So this x times the quantity x plus 1. So this is what I'm going to multiply both sides of the equation by to clear all the denominators. So we have x times the quantity x plus 1. And that's going to be multiplied by 1 over x plus 1. This equals 5 over x plus 1. Again, times this x times the quantity x plus 1. Then plus, we have x plus 7 over x times the quantity x plus 1. And this is times x times the quantity x plus 1. Let's cancel this with this. And you can wrap this in parentheses if you need to. It's not necessary, but some people like that. Let me wrap this as well. So I'm going to cancel this with this. And then I'm going to cancel this with this. So the x's would cancel. And then this with this. Okay. What do I have left? And again, this is tricky because sometimes you think this whole thing is canceled, but you still have this x here and you have this 1 here. So you have to be really, really careful when you solve these types of problems. So this is going to be x times 1, or just x, is equal to, this is 5 times x, so that's 5x. And then plus, over here you have this x plus 7, and that's it. Everything else is canceled away. So x plus 7. Okay, so what does this give me? Well, 5x plus x is 6x. So let's say that x is equal to 6x plus 7. Let's subtract 6x away from each side and cancel this away. This would be negative 5x is equal to 7. Let's divide both sides of the equation by negative 5. Let's cancel this, and we'll say x is equal to negative 7/5. Now, one thing you could do when you start getting all these different fractions involved, you can divide this in your calculator. You're going to get negative 1.4, so that's the decimal answer. And that might be easier to work with because when you work with fractions, obviously you have to get all these common denominators, and that takes time. But again, let's first think about the domain and whether this violates it or not. So here you have x plus 1, here you have x plus 1, here you have x plus 1. So you set x plus 1 equal to 0 and you solve that. So we know that x cannot be negative 1. But also you have this x hanging out right there. So you have to set that equal to 0 as well. And that would just be x equals 0, right? So if you plug in a negative 1 or a 0 for x, you would end up with division by 0. And again, that's undefined. So we would say that our domain here is the set of all x. So let me write that in there. I just need to slide this down. So again, the set of all x such that x is not equal to negative 1 or 0. So let's close that. And then essentially I would just plug this in to make sure that I didn't make an error. Right now I know that I didn't violate the domain. So again, if I'm on a timed exam and I just want to go through it quickly, well then I would just say, okay, this does not violate the domain. So I would just move on. But just for completeness, let's plug in a negative 1.4. And then I'll make a little border there. So you'd have 1 over, again, I'm just going to use negative 1.4. And if I add that to 1, I'm going to get negative 0.4. Then this equals, you have 5 over negative 1.4 plus 1, again, is negative 0.4. And then plus, you have this negative 1.4 plus 7 over, you have negative 1.4 times your negative 1.4 plus 1. And again, this is going to be negative 0.4. So this guy right there. So this is something I would just do with a calculator really quickly. 1 divided by negative 0.4, that's going to be negative 2.5. So this is negative 2.5. Or if you were working with fractions, you would have got negative 5/2. Then over here, 5 divided by negative 0.4, that's negative 12.5. So let's say this is negative 12.5. And then over here, negative 1.4 plus 7, that's 5.6. And then over here, negative 1.4 times negative 0.4, that's going to be 0.56. So 0.56. If you do this division here, you're going to get 10. So let's erase this and put 10. And then negative 12.5 plus 10 is going to give me that negative 2.5. So you get negative 2.5 is equal to negative 2.5. Or again, if you were working with the fractions, you get negative 5 halves equals negative 5 halves. But again, that's going to take a lot longer because you do have to get common denominators. Either way, this answer here, which is x equals negative 7/5, or you could say x equals negative 1.4, that solution is correct. All right, let's take a look at problem number 3 now. So we have x plus 2 over x squared minus 3x. Then plus we have 7 over x, and this equals 1 over x minus 3. So the idea is I'm just going to factor this denominator here. So I'll say this is x plus 2 over x times the quantity x minus 3. Then plus I'll have 7 over x. Can't do anything with that denominator. Then this equals 1 over x minus 3. Can't do anything with that denominator. Okay. Looking at this guy, this has an x here, and this has an x here. Then this has an x minus 3 here, and this has an x minus 3 here. So the LCD would just be the x times the quantity x minus 3. So let me actually put a box around this. I'm just going to multiply both sides of the equation by that so I can clear all my denominators. So let's say we have x plus 2 over x times the quantity x minus 3. And then this is times x times the quantity x minus 3. Then plus 7 over x times x times the quantity x minus 3. And this equals 1 over x minus 3 times your x times the quantity x minus 3. Okay, let me actually wrap this, and I'm going to wrap this just for clarity. It's not necessary, but a lot of students need it. So I'm going to cancel this out with this out, right? X divided by x is 1. The quantity x minus 3 divided by the quantity x minus 3 is 1. So that's gone. Then this is going to cancel with this. Again, you could wrap this in parentheses if you want. It's really personal preference. Then this is going to cancel with this. Okay, what's left? Over here, it's x plus 2. So x plus 2. Then plus. Here, it's 7 times the quantity x minus 3. You have to keep the 7 out in front of those parentheses because the 7 needs to multiply by the x and then the negative 3. A very common mistake when you solve this type of problem is to just say it's 7x minus 3, and the 7 needs to multiply by both. Okay, so it's very important. Then this equals, you have 1 multiplied by x, which is just x. So I'm just going to say this is x plus 2 plus 7 times x is 7x, and then minus 7 times 3 is 21, and this equals x. So let's combine like terms here. X plus 7x is 8x, and then 2 minus 21 is negative 19, and this equals x. So what I'll do is subtract x away from each side, and I'll add 19 to both sides. And so let's cancel this away and cancel this away. I'll have 8x minus x, which is 7x, and this equals 19. Okay, let's divide both sides of the equation by 7, and we'll cancel this 7 with this 7 and say x is equal to 19 sevenths. Okay, coming back up here, again, you could just make sure it doesn't violate the domain, or you could check it completely. I'm going to do both. So I'm just going to say that my domain here is found. So it's the set of all x such that, well, you have this factor of x. So you need to set that equal to 0, and basically that's your x is not equal to 0 there. That's pretty simple. Then the other guy is x minus 3. So set that equal to 0. If you solve that, you get x is equal to 3. So x can't be 0 or 3, right? In either case, if you plugged in a 0, you would get a denominator here and a denominator here, which is 0, right? You'd be dividing by 0, which is undefined. And then if x was 3, then this denominator here and this denominator here would be 0. And again, division by 0 is undefined. So these are our two restricted values, this 0 and 3. So our domain is the set of all x such that x is not 0 or 3. Now 19 sevenths, that doesn't violate anything. So again, if you're in a hurry, just put that down and move on. But let's go ahead and check this for those that want to. And for this one, if you divide 19 by 7 in your calculator, you're going to get a pretty nasty decimal. It's a repeating decimal. So I would probably just go through and get common denominators here and just stick it out. So this would be 19 over 7 plus 2. So that's going to be 14 over 7. So 14 over 7. And all I did was multiply 2 by 7 over 7. So 19 plus 14, that's 33. So this top part here is 33 over 7. Down here, you have 19 over 7. Let me do this off to the side. So we have 19 over 7 times your quantity, 19 over 7 minus, for 3, I'm going to write that as 21 over 7. So this is going to be negative 2 over 7. So this is negative 2 over 7. And if I multiply 19 times negative 2, I get negative 38, and 7 times 7 is 49. So this would be negative 38 over 49. So this is divided by negative 38 over 49. So I'm just writing it with the division symbol here versus the fraction bar. And we know that we're going to take this first guy, which is 33 over 7, and multiply by the reciprocal of this guy, so 49 over negative 38. So then I'm going to cancel this with this and say this is a 7. And that's basically all I can do. So I would say 33 times 7 is 231, and this is over basically 1 times negative 38, which is negative 38. Okay, let's erase all this. So now we have plus, we have 7 over this 19 over 7. So again, you could write this as 7 divided by your 19 over 7 like this. So you could go 7 over 1. And then all you'd have to do is multiply by the reciprocal. So you'd flip this and say this is 7 over 19. And so this gives me 49 over 19. So this is 49 over 19. And this equals, over here you'd have 1 over. So you have x, which is 19 over 7. So 19 over 7, and then minus 3. Again, we did that before. That's 21 over 7. So 19 minus 21 is negative 2. So this is negative 2 over 7. So negative 2 over 7. Now with this 1 being divided by this, you could just take the reciprocal of this negative 2 sevenths. So this is negative 7 halves there. And so that's what we're looking for this side to be equal to. So at this point, I could just multiply this by 2 over 2. So 49 times 2 is 98. So this would be 98. And 19 times 2 is going to be 38. Okay. What I'll do is move this negative up here. So negative 231 plus 98, that's negative 133. So basically, what you'd want to do is reduce this guy. And if you cancel a common factor of 19 between the numerator and denominator, you're going to end up with negative 7 halves. So I know this took forever, but we did verify our solution. So x equals 19 over 7. All right, let's take a look at problem number 4 now. So here we have 4 over 5x plus 7. Then minus, we have 6 over 5x cubed plus 52x squared plus 63x. This is equal to, we have x plus 3 over 5x cubed plus 52x squared plus 63x. So this one is a bit tedious, but I think it's good to have an example like this. So the first thing you would do is obviously factor this 5x cubed plus 52x squared plus 63x. Okay, let me write that out. So 5x cubed plus 52x squared plus 63x. Well, the first thing is, can I pull anything out? Well, if you look at 5, that's a prime number. And then you go to 52, that's not divisible by 5, so you can stop there. But you do have an x cubed, an x squared, and then an x. So I could pull out an x. So let me start by just doing that. So I'm just going to say this is x times, inside I'll have 5x squared, and then plus I'll have 52x, and then plus 63. Okay, from here, what I'm going to do is say I have my x outside. Let me set up my parentheses here. And again, 5 is a prime number, so that actually works to our benefit. So I'm just going to say this is 5x and this is x. Now, for 63, it's really not that bad. It's either 1 times 63, or it's 9 times 7, or it's 3 times 21. So really, there's only 3 things you need to check. So 1 in 63, that's not going to work because, again, you're going to have all plus signs here because everything's a plus. If you put the 63 here, it's too big, and it's also too big if you put it here. So that's out. So then you would have 9 and 7. So would that work? If you put a 9 here and a 7 here, your outer is going to be 45x and your inner is going to be 7x. Well, 45x plus 7x is 52x. Okay, so this is our factorization of this guy. Let me erase everything. And I'm going to have to write this really, really small to fit everything on the screen. 4 over 5x plus 7. And then minus, you'll have 6 over this guy right here. So x times the quantity 5x plus your 7 times the quantity x plus 9. And then we'll say this is equal to, you have this x plus 3 over, you have x times the quantity 5x plus 7, and then times the quantity x plus 9. Okay, let's extend that a little bit. All right, let's get rid of this. And now let's think about our LCD. If we look across here, we have this 5x plus 7, which is here and here and also here. So we know that goes in. Then also we have this x, which is here and here, so that goes in. And then we have this x plus 9 here and here, so that goes in. So the LCD, let me just put a box around this one. The LCD is this guy right here. Obviously, it's also this guy right here. Now, trying to fit this on the screen is really, really difficult. But basically, you're going to take this guy right here, this LCD, and multiply it by each guy in the equation. So we know that in this case and in this case, the denominators are going to cancel completely. And so for here, you're going to have -6, and here you're going to have x plus 3. Okay, so I'm just going to do this one first over here. That way I can do it the long way. And then we know it's going to cancel over here. So 4 over 5x plus 7, and then times this x times the quantity 5x plus 7 times the quantity x plus 9. And so basically this would cancel with this. And so you would have 4x times the quantity x plus 9. Okay, let me write that up here. And then I'm going to go minus. Again, this would cancel completely, right? So we don't have to write that out. We know it's just -6. And this equals, this would cancel completely. So you're just going to have the x plus 3. Okay. So from here, it's not that bad. We're just going to end up with a quadratic that we have to solve. So this is going to be 4x times x, that's 4x squared. And then plus 4x times 9 is going to be 36x. And then -6 is equal to x plus 3. I want to subtract 3 away from each side and cancel this. I want to subtract x away from each side and cancel this. Let's put a 0 over here. Let's say this is 4x squared. And then 36x minus x is 35x, so plus 35x. And then -6 minus 3 is -9, and this equals 0. All right, so can we solve this using factoring? I think we should give it a shot. If you're not comfortable with this, again, you can just use the quadratic formula. So let me set this up here. I'm just going to use reverse FOIL. Again, you could also use the AC method if you want. Now, 4 is not a prime number. It's either 1 times 4 or 2 times 2. I would start with 4x and x and see if I can make that work. This is a minus here, so I'm going to need to subtract. Again, in terms of absolute value, I'm trying to get to 35, okay? So 9 is either 1 times 9 or it's 3 times 3. So if you put the 9 here and the 1 here, you're going to see that this is going to work right away, right? So basically, if you make this a positive and this a negative, then this is going to be 36x, and this is going to be minus x. So 36x minus x is 35x. So this is our factorization. So sometimes we get lucky and we get it right away, and other times we have to go through all of the possibilities before we find it. So this is going to be 4x minus 1 is equal to 0, or x plus 9 is equal to 0. So let's add 1 to both sides of the equation here. This will give me 4x is equal to 1. Divide both sides by 4. We'll cancel that and say x is 1/4. Over here, let's subtract 9 away from each side. We'll cancel this. So also x could be -9. Now again, we have to check these. Okay, so the first thing is we want to make sure we don't violate the domain. And then we could also check to make sure that the left and the right sides are equal. But again, you need to, at minimum, make sure you're not violating the domain. So the domain here is going to be the set of all x such that x is not equal to, well, first off, you have this x here. So you can think about this factor here. If you set that equal to 0, well, it's just x equals 0. So one value that x can't be is 0. Then the other guy is 5x plus 7. You'd have to set that equal to 0 and solve. Subtract 7 away from each side. Cancel this. You would have 5x is equal to -7. Divide both sides by 5. And so x can also not be -7/5. Then the last guy, we would take x plus 9 and set that equal to 0. And we would say that the solution there is x equals -9. Okay. So let's look through our solutions here, because again, the domain is a set of all x such that x is not 0, -7/5, or -9. Now, what do we see right here? We have a solution of -9. So we have to reject that solution. It's extraneous, right? So if you plugged in a -9 for x here or also here, what's going to happen is you get -9 plus 9, that's 0. And 0 times anything is 0. So you're going to end up dividing by 0 here and also here. And so we end up with something that's undefined. Okay, so again, we have to reject that solution. So the other solution is 1/4. So that does not violate the domain, so we just need to check that. So you're going to have 4 over your 5 times x. So this is 5 times 1/4, and then plus 7, and then minus 6 over. You have this 1/4 times this 5 times 1/4. And then basically plus 7, and then times, you're going to have this 1/4 plus 9 here. And let me just stop here. Let me figure out this side, and then I'll figure out this side. We'll be able to take this answer right here and share it with this one, so that'll speed up the process a little bit. Over here, 5 times 1/4 is 5/4. So this is 5/4, and then plus 7. So we'll need a common denominator. So let's say this is 28 over 4, and 5 plus 28 is going to be 33. So this is 33 over 4. Okay. For this guy right here, I can go ahead and say that this is 33 over 4, right? Because it's the same. The 5x plus 7 here is the same as the 5x plus 7 here. So let's just say this is 33 over 4. And then what I'll do is say 4 is multiplied by the reciprocal of this. So 4 is going to be multiplied by this 4 over 33. So that's 16 over 33. So this is 16 over 33. Okay, over here I'm going to write 9 as 36 over 4. And so this would be 37 over 4 if I do the addition. And let's see what we get. So 33 times 37, that's 1,221. So let's write that. So this is going to be 1,221. And then 4 times 4 times 4 is going to be 64. So this would be over 64. Okay, I'm going to share that answer with this over here. So I'm just going to write 1/4 plus 3 over here, and then over 1,221 over 64. Okay, so coming up here again, I just want to flip this. So I'm going to say 6 is multiplied by the reciprocal of this. So 6 times this 64 over 1,221. Let's get rid of this. And we know this is not an even number down here, but 1 plus 2 is 3, 3 plus 2 is 5, and 5 plus 1 is 6. So that tells me that this is divisible by 3, and so is this. If I divide this by 3, I'm going to get 407. And if I divide this by 3, I'm going to get 2. So basically, 2 times 64 is 128. So this is what we have over here. Let me slide this over. All right, now at this point, we need to get a common denominator. If you think about 33, it's going to be 3 times 11. So this is 3 times 11. For 407, 4 plus 0 plus 7 is 10. So you know it's not divisible by 3. But if you check to see if it's divisible by 11, you're going to see that it's 37 times 11. Okay, so the LCD would be what? It's 3 times 11 times 37. So 3 times 11 times 37, which is that 1,221 that we saw before. So I'm going to multiply this guy by what I need. So that's going to be 37 over 37. And then this guy is going to get multiplied by 3 over 3. Okay, let's get rid of this and let's see what we have. So 16 times 37, that's 592. So this is 592. And of course, 33 times 37 is 1,221. Then over here, 128 times 3, that's 384. And again, 407 times 3, that's 1,221. So this is 1,221. 592 minus 384, that's 208. So you would have 208 over 1,221. This guy right here, this 208 is going to be basically 16, or you could say 2 to the 4th power times 13. And this 1,221, that's going to be our 3 times 11 times 37. So we know there's nothing in common between the numerator and denominator, so that's going to be simplified. Okay, thinking about this over here, let me get rid of this equal sign, and I'll just bring this down a little bit. So 1/4 plus 3, let's just say this is 12/4 like this. And basically this would be 13/4. So let's say this is 13 over 4 times the reciprocal of this, which is 64 over 1,221. And let's see what this is going to give us. 64 divided by 4 is going to be 16. So this would be 16. And we just said that 16 times 13 is 208. So we see that this would be 208 over 1,221. So although it took forever, we see that the left side and the right sides are equal. So this is a valid solution. Again, if you get something that's this difficult to check, you can just use your calculator. Or if you want to do it the long way, I would wait until your test is over and then come back. As long as you didn't violate the domain here, you should be good as long as you didn't make a silly mistake. All right, let's take a look at problem number 5 now. So we have 3x minus 24 over x squared minus 6x. This is equal to 1 over x minus 6, then plus 1 over x. So what I'm going to do is just write this as 3 times the quantity x minus 8. I'm just going to factor the numerator just in case something cancels. Then this is over. Down here I'm going to have x times my quantity, x minus 6. Now, turns out nothing's going to cancel, but I'm just going to keep it in factored form. That's the way I like it. Then this equals, we're going to have 1 over x minus 6. And then plus 1 over x. Okay, what is the LCD here? Well, you see that here you have x and here you have x. Then here you have the quantity x minus 6 and here you have the quantity x minus 6. So your LCD is just going to be this guy right here, your x times your quantity x minus 6. Okay, so let's write 3 times the quantity x minus 8 and then over x times the quantity x minus 6 and then times x times the quantity x minus 6. Then this equals, you have 1 over x minus 6 times your x times your quantity x minus 6, then plus your 1 over x times your x times your quantity x minus 6. This will cancel with this, and so I'm left with this 3 times the quantity x minus 8. Now you can do that now if you want and just say this is 3x minus 24. Then this equals let me wrap this. This would cancel with this. So you have x times 1, which is just x. Then plus, this would cancel with this. And you have 1 times this quantity x minus 6, which is just x minus 6. Now to simplify, let's write 3x minus 24 is equal to x plus x is 2x, then minus 6. What I'll do is subtract 2x away from each side. Let's cancel that. And let's add 24 to both sides. Let's cancel that. So 3x minus 2x is x. That's equal to negative 6 plus 24. That's going to be 18. So x equals 18. That's our answer. Okay, so let's figure out, again, what is the domain and make sure that this guy is not going to violate it. So the set of all x such that x is not equal to. Well, in this case, you would set x equal to 0, so it's just 0. And then you would set x minus 6 equal to 0, so that's going to be a solution of x equals 6. So x here can't be 0 or 6. Again, plugging either of those in for x would result in a denominator that's 0, and again, division by 0 is undefined. So 18 does not violate the domain. So again, if you're in a hurry, you can just put that down as your answer and move on. But for completeness, I'm just going to plug it in and check, show you the left and the right sides are equal. So I'm going to say that 3 times a quantity, you would have 18 minus 8, which is 10. And 3 times 10 is 30. Let's just put that in there now. So let's just say this is 30. And this is over. You would have 18 times your quantity. 18 minus 6 is going to be 12. So before I multiply here, let's just cancel. 30 divided by 6 is 5. And then 18 divided by 6 is 3. So basically, this is 5 over 36. So let's write this as 5 over 36. This is equal to. Over here, you have 1 over. You have 18 minus 6, which is 12. And then plus 1 over, you have 18. Now, you would have to get a common denominator here. In the LCD, when you consider 12 and 18, this right here is basically 2 squared times 3. And this right here is 2 times 3 squared. So you need 4, or 2 squared, times 9, or 3 squared. So 36 is the LCD. So I'm going to multiply this by 2 over 2. And I'm going to multiply this by 3 over 3. And so you're going to get 3 over 36. So 3 over 36. And then plus, you're going to have 2 over 36. So 2 over 36. And obviously, this would be 5 over 36. So we have verified our answer here of x equals 18. Because again, the left and the right sides are equal. And of course, we do not have a domain violation here. All right, let's take a look at problem number 6. So here we have 1 is equal to 1 over x plus x squared minus 2x minus 3 over x squared plus 6x. Okay, the first thing I'm going to do is just factor everything that I can. So 1 is equal to 1 over x. And then plus, this guy up here, can I factor that? I need two integers whose sum is negative 2 and whose product is negative 3. X minus 3, that quantity, times the quantity x plus 1. And this would be over. Down here, I'm going to factor out the x, and I'll have x plus 6 inside the parentheses. Okay. Nothing's going to cancel here, so I've checked that. And just looking at my LCD, we can see that there's an x here and an x here. And then here you have the x plus 6. So it's x times the quantity x plus 6. So this would be your LCD here. Now, I'm going to multiply both sides by this LCD. So this 1 multiplied by this would just give me this. So this is x times the quantity x plus 6. And this equals, over here, this would be 1 over x times this guy. So you just write it up here to save some space. So x times the quantity x plus 6. And then we're going to have plus, we'll have this x minus 3 times the quantity x plus 1 over your x times your quantity x plus 6. And this is multiplied by, again, x times the quantity x plus 6. Okay, so nothing to cancel over here. This is going to cancel with this. And then this is going to cancel with this. Okay, so over here, I'm just going to go back to that form of x squared plus 6x. And this equals, over here you have x plus 6. And then plus, here we're just going to undo what we did when we factored. So this is going to go back to x squared minus 2x and then minus 3. Looking at this now, you see that there's an x squared here and an x squared here. So I could subtract x squared away from each side of the equation. That would disappear. X minus 2x would be negative x. So let's say this is 6x is equal to negative x. And then 6 minus 3 would be 3, so plus 3. Let's add x to both sides. And we'll cancel this away. We'll say 7x is equal to 3. Let's divide both sides by 7. We'll cancel that and say x is equal to 3/7. Okay, so coming back, let me say my domain is what? The set of all x such that, well, here you have this x, right? So x can't be 0, so x is not 0. And then additionally, you would set x plus 6 equal to 0. You'd solve that, and x can't be negative 6. So x can't be 0 or negative 6. So again, set of all x such that x is not 0 or negative 6. That's your domain. And so 3/7 does not violate that, right? We're in the domain, so we're good to go there. Now trying to plug in a 3/7 for x here and here and here and here and here, it's going to be pretty tedious. I'm just going to tell you because you have to get a lot of common denominators. Now you could plug the whole thing in, the whole right side into your calculator. If you do it correctly and you wrap everything, you will get 1. Okay, so you can do it like that. It's really up to you. If I was on an exam, I'd probably do it that way just to check. But I think we could do it the long way just to get some practice. So we have 1 is equal to, now 1 divided by 3/7, you just flip that at 7/3. Then plus. Here you can have 3/7 minus 3. So let's do 3/7 minus 3. Then this is multiplied by 3/7 plus 1. Then this is over. You have 3/7 times your quantity 3/7 plus 6. So a lot of common denominators to get. So for this one, you basically have negative 21 over 7. And then for this one, it would be 7 over 7. And then for this one, it would be 42 over 7. And basically, let me make that a little bit better. So this is 42 over 7. You put that fraction bar back in there. So 3 minus 21 is going to be negative 18. So this is negative 18 over 7. So we have negative 18 over 7. And then basically for this one, 3 plus 7 is 10. So this is 10 over 7. So this is 10 over 7. So I can't cancel anything. So negative 18 times 10 is negative 180. And then 7 times 7 is 49. So this is negative 180 over 49. Down here, 3 plus 42 is 45. So this would be 45 over 7. And if I multiply here, nothing's going to cancel. So 3 times 45, that's 135. And that would be over 7 times 7, which is 49. So this is 135 over 49. Okay, we're going to take this guy and multiply by the reciprocal of this guy and see what we get. So let's get rid of this. So let's cancel this with this. Now 135 is going to be 5 times 3 cubed. And then 180 is going to be 2 squared times 3 squared and then times 5. Well, you would basically cancel a common factor of 5 and a common factor of 3 squared or 9. So essentially in the numerator, you're going to have a negative 4. So let's write negative 4. And in the denominator, you're going to have a 3 to the first power. So 3 to the first power. Let me actually get rid of this. So this is going to be negative 4/3 here. Okay. So if we have 7 plus negative 4, that's going to give me 3. And this would be over the common denominator of 3. And 3 over 3 is 1. So again, we verified our solution. I know it takes a while, but we verified that x equals 3/7 is valid. All right, let's take a look at problem 7. So we have x over 2x squared plus 10x plus 8, then minus x minus 7 over x plus 4, and this equals 1 over x plus 1. Let me just rewrite this. All right, so let me put x over. Before I factor this, notice that you could pull out a 2. It's going to make it a lot easier. So then you would have this x squared, and then plus 5x, and then plus 4. So this is 2 times the quantity. You'd have an x here and an x here. 2 integers that sum to 5 and have a product of 4. That's going to be 4 and then 1. Let's get rid of this, and then let's slide this up here. Okay. Then minus, you have x minus 7 over x plus 4. And then this equals 1 over x plus 1. Now, what's the LCD? You have a 2 here that's going to have to go in. You have this x plus 4 occurs here and here once each time. And then an x plus 1 that occurs here and here. So this guy right here is going to be your LCD, right? So this 2 times the quantity x plus 4 times the quantity x plus 1. So if I multiply both sides by the LCD, this is going to cancel, okay? So we're going to say that this is just x over here, then minus. So this is going to get multiplied by this right here. So let me write this one out. So x minus 7, I'm going to wrap this, and then this is over this x plus 4, and it's multiplied by this 2 times the quantity x plus 4 times the quantity x plus 1. Now to save space, because I'm not going to be able to fit this, I'm just going to cancel this with this, and I'm just going to get rid of it so that we have some room. Otherwise, we won't be able to fit this. So I'm just going to write this as 2 times the quantity x minus 7 times the quantity x plus 1. Let's get rid of this, and then I'll just bring this in line like this. And then lastly, you have equals. You're going to have this 1 over. You have this x plus 1 quantity. Again, multiplied by the LCD. So 2 times the quantity x plus 4. Let me slide this down so it fits. Then times the quantity x plus 1. And again, I'm just going to cancel this now and remove it. So this is going to be canceled with this. I'm just going to get it out of here. just so it all fits nicely. So this 1 was multiplied by that. So this is just 2 times the quantity x plus 4. Okay. So now thinking about this, we just want to simplify and see where that leads us. So x and then minus. So this is where you have to be really, really careful. You are subtracting this whole thing away. So you might want to put some brackets here or parentheses or whatever, and then just do the result of this, and then you can distribute the negative to each term inside and then remove your brackets or parentheses. So x times x is x squared, and then basically you have 1x minus 7x, which is negative 6x, and then negative 7 times 1, that's going to be minus 7. So this guy right here would get multiplied by 2. Let me close that down. So this would be 2x squared minus 12x and then minus 14. Let's remove this and just drag this up here. Now, if you want to go through and simplify here, you're going to basically change the sign of everything. So this is going to be a minus, this is a plus, and this is a plus. And now you can get rid of all this and move this over. So basically you want to make sure that if you're subtracting something like this away, wrap it in parentheses or brackets or something like that so that you don't make a sign mistake. Okay, that's very important. Then this equals over here, you'll have 2x plus 8. Okay. Now thinking about simplifying here, on the left-hand side, I have x plus 12x. That's going to be 13x. So let me write negative 2x squared, and then basically plus 13x, and then plus 14. And this equals your 2x plus 8. I'm going to subtract 2x away from each side. We'll cancel that. I'm going to subtract 8 away from each side. We'll cancel that. So this is 0. So you're going to have negative 2x squared. And then 13 minus 2 is 11, so plus 11x. And then 14 minus 8 is 6, so plus 6. And this equals 0. All right, to make this a little bit easier, I'm going to divide everything by negative 1. And I'm just doing that so that the leading coefficient here is going to be a positive. I don't like factoring when it's negative, so you can just do this. This would give me 2x squared, and then minus 11x, and then minus 6, and this equals 0. Okay, let's solve this using factoring. Again, if you don't like this, you can just use the quadratic formula. So we have 2x, and then we have x. So basically, this is a minus here. So I'm going to be subtracting, okay? And I want to think about getting to 11 in terms of absolute value. Forget about the fact that it's negative 11. So for 6, it's 1 times 6 or it's 2 times 3. Now, I can't put the 6 here, okay, but I could put it here, right? You can't put it here because you have a common factor of 2. There's no common factor of 2 there. Does this work? Well, this is going to be 12 minus 1, which is 11. So this needs to be a negative, and this needs to be a positive, and that's what we want, right? This is negative 12x. This is x. And basically, negative 12x plus x is negative 11x. So this is what we want. And I didn't mean to do that. So let's come down here and say 2x plus 1 equals 0, or x minus 6 equals 0. So here we subtract 1 away from each side. We say 2x is equal to negative 1. Divide both sides by 2. We'll say x is equal to negative 1/2. Over here, let's add 6 to both sides. Let's cancel this. So also x could be 6. So let's grab these. So coming back up here, again, let's think about our domain. So what is the domain? So the set of all x such that x is not equal to, again, thinking about this, 2, you don't have to set that equal to 0, obviously. You just take factors with a variable. So x plus 4 gets set equal to 0. You solve that, you get negative 4. And then x plus 1 gets set equal to 0. You solve that, you get negative 1. So the domain is the set of all x such that x is not negative 4 or negative 1. Okay, you have negative 1/2 and 6. So you haven't violated the domain. So again, if you're on a timed exam, just move on, right? And you can come back later if you have time. But I'm going to check this and make sure that it works. Now, the benefit of negative 1/2, you can use negative 0.5 and just plug that into your calculator, and that should be pretty quick to do. So let's go ahead and do this in our calculator. So I'll say this is negative 0.5 over 2 times, you're going to have negative 0.5 plus 4. Let's just say that's 3.5. That'll be easier to punch in. And then over here, your negative 0.5 plus 1, that's going to be 0.5. And then we'll have minus. You can have negative 0.5 minus 7. Let's just go ahead and say that's going to be negative 7.5. This will be over. You have negative 0.5 plus 4. So we already know that's 3.5. And this should be equal to 1 over negative 0.5 plus 1 is 0.5. Now I know that 1 divided by 0.5 or 1 divided by 1/2 is 2. So I'm just going to erase this and put 2. You could punch this into your calculator and make sure you get 2. I'm just going to tell you in advance that you will get it. So I'll just let you punch that in on your own. Just make sure to wrap this in parentheses and this whole thing in parentheses when you're dividing, because if you don't do things like that, you're going to make a mistake and you're going to think that you got the wrong answer. So this will end up being 2 is equal to 2. Okay, so that's verified. So over here, now we have 6. So this is something pretty easy to work with. So you'd have 6 over 6 plus 4 is 10. And then over here, 6 plus 1 is 7. So 7 times 10 is 70, times 2 is 140. Now, you could cancel a common factor of 2 there. So this would be 3, and then this would be 70 here. Now, coming over here, you'd have 6 minus 7, which is negative 1, over, if you have 6 plus 4, that's 10. Now, what I would do here is say minus a negative is plus a positive. So I'll just say this is a plus here. And then essentially I would multiply this by 7 over 7. So this would be 7 over 70. So this would end up being 10 over 70. So 10 over 70, or 1/7. So this is 1/7. Then this equals, you have 1 over, again, 6 plus 1 would be 7. So 1/7 equals 1/7. So this guy is verified as well. So x here can be negative 1/2 or 6. All right, let's take a look at problem number 8 now. So we have 1 minus 7 over x is equal to, we have 6x squared plus 12x minus 18. This is over x squared plus 4x. So let's write 1 minus 7 over x. This equals, up here, let me pull out a 6. That would give me x squared, and then plus 2x, and then minus 3. And I could further factor that. If you want two integers whose sum is 2, and whose product is negative 3, well, that's going to be positive 3 and negative 1. So this is 6 times the quantity x plus 3 times the quantity. You'll have x minus 1. Okay, let's replace this with this. And I'm just doing this to see if anything's going to cancel. I think you can eyeball that and see it's not going to. But again, you have the unfactored form if you need to work with it that way. So I prefer to have both. So down here, I'll have x times the quantity x plus 4. Okay, so the LCD is obviously going to be x times the quantity x plus 4. You have an x here and an x here. And then here you have this x plus 4. All right, so we would multiply both sides of the equation, again, by this LCD. So this, if I multiply 1 by this, I'm just going to get it. So x times the quantity x plus 4, or again, you could just say it's x squared plus 4x. We might as well just do that because we're going to have to distribute it anyway. And then minus, you're going to have 7 over x times this x times the quantity x plus 4. Again, because it's hard to fit all this stuff on the screen, I'm just going to cancel stuff as I go and say this cancels with this. So you would erase this and say 7 times the quantity x plus 4. Let me slide this down here and then slide this down like this. Then we could say this equals, well, if this guy here gets multiplied by the denominator, well, then the denominator is going to cancel, right? So I would just have 6 times the quantity x plus 3, and then times the quantity x minus 1. So on the left side, let's say we have x squared, and then plus 4x. And then this negative 7 is multiplied by x, so that's negative 7x. And then negative 7 times 4, that's minus 28. And this equals, then for this one, we can go to our unfactored form. So that was 6x squared, and then we had plus 12x, and then minus 18. Looking at this, we can see we have a quadratic. So I'm just going to put this into standard form. So let's go ahead and subtract x squared away from each side. This will cancel. And then 4x minus 7x is going to be negative 3x. So let me just write here that this is negative 3x. I'm just going to line that out. And then basically I would add this 3x to both sides. And then I'll cancel this away. And then I'm going to add 28 to both sides. And then I'll cancel this away. So this is 0 over here. And I'm just going to flip the sides because I like my variable to be on the left. So I'll say 6 minus 1 would be 5. So this is 5x squared. And then 12 plus 3 is 15. So plus 15x. And then negative 18 plus 28 is 10. So plus 10. And this equals 0. So of course you could factor out a 5 or you could divide everything by 5. It's probably better to divide everything by 5 because then you don't have to think about it anymore. And so this would give me x squared plus 3x plus 2 is equal to 0. So this left side here would factor. This would be an x and this would be an x. And so essentially you would think about two integers whose sum is 3 and whose product is 2. So this is plus 2 and plus 1. So you have x plus 2 is equal to 0, or x plus 1 is equal to 0. So x is negative 2, or x is negative 1. So let me write this in a more compact way. So x equals negative 2 or negative 1. Okay, so coming back and thinking about my domain. So what is my domain? And I'll just say that it's the set of all x such that we see we have an x here. Again, you set that equal to 0, so x can't be 0. So x is not equal to 0. And then also x plus 4, this factor here would be set equal to 0. So if you set x plus 4 equal to 0, the solution is x equals negative 4. So you have negative 4 there as well. So the domain is the set of all x such that x is not 0 or negative 4. So again, just looking through this, I'm not violating the domain. So again, if you're in a hurry, just put that answer down and move on. Now again, to check this fully, I'm going to say this is 1 minus. If you go 7 over negative 2, you might as well say this is plus 7 halves. And then we could just say this is 2 over 2 here. And so basically this left side would be 9 halves. So this is 9 halves, or if you're doing this with your calculator, it's 4.5. And then over here, you think about 6 times, you'd have negative 2 plus 3, which is 1. And then times negative 2 minus 1, which is negative 3. And this is over, you have your negative 2 times your negative 2 plus 4, which is 2. Let me go through and fix this. This is a 3 here. So let's say that we have this 6 right here would cancel with, let's just say this 2 here, and that gives me a 3 here. So 3 times negative 3 would be negative 9. So this would be negative 9. And then down here, you just have the negative 2. Well, negative divided by negative is positive, so you'll just say that you have 9 halves equals 9 halves. So this is a verified solution. Now for negative 1, you have 1 minus 7 over negative 1. So again, this is minus a negative is plus a positive. So let's say this is 1 plus 7, which is going to basically be 8. Okay, so this is 8. That's what we're looking for. And then over here, you have 6 times negative 1 plus 3 is going to be 2. And then times negative 1 minus 1 is negative 2. This is over. You have negative 1 times, you have negative 1 plus 4, which is 3. Okay, so let's go through here. I'm going to cancel this with this and get a 2 here. So essentially, cancel this negative with this negative, and I'll have 2 times 2 times 2, which is 8, and so you get 8 equals 8. Okay, so this is 8 equals 8. So again, this is verified. So our solutions here, x equals negative 2 or x equals negative 1. Again, they don't violate the domain, and we also saw that the left and the right sides were equal. All right, let's take a look at problem number 9 now. So we have 1 minus, I'm going to factor this 2 out. So 2 times the quantity x minus 3. This would be over x, and this equals, up here, let's factor out the 3. That would give me x squared plus 7x minus 8. And then you could factor this further. If you want an x here and an x here, and 2 integers whose sum is 7 and whose product is negative 8, well, that's going to be positive 8 and then negative 1. Down here, you could factor that as x times the quantity x minus 5. Now, this is going to be your LCD, right? The x times the quantity x minus 5. Again, when you think about it, you have an x here and an x here, and then you have this x minus 5 there, okay? So coming down here, and again, it's really hard to fit this on the screen, but we're basically going to multiply this guy right here by everything in this equation. So if I multiply it by 1, I just get x times the quantity x minus 5, which I might as well just write as x squared minus 5x. Then minus. Here's where I'm going to put some brackets, or you could use parentheses or whatever. This is going to multiply by this, okay? So we know that the x's would cancel. So you're going to have 2 times the quantity x minus 3 times the quantity x minus 5. And again, this x right here is going to cancel with this x right here if x times the quantity x minus 5 is multiplied by this guy right here, okay? So I would have to simplify this, and I'll do that in a moment. Then this equals, again, if I multiply this guy right here by this LCD, or this denominator, well, the denominator is going to cancel. So I have the 3 times the quantity x plus 8 times the quantity x minus 1, which in unfactored form, again, was 3x squared plus 21x minus 24. Okay, let's see what we can do here. So over here, we have x squared minus 5x and then minus. So first I would say x times x is x squared. And then you would have your outer, which is negative 5x, your inner, which is negative 3x, so that's negative 8x. And then negative 3 times negative 5 is plus 15. Now, this is going to get multiplied by 2. Okay, so 2 times x squared is 2x squared. And then basically 2 times negative 8x is negative 16x. And then 2 times 15 is 30. So let me replace this with this. Now here's where those brackets really come in handy. This negative has to be distributed to each term here. Okay, so I'm going to drop this, and basically I'm going to change the sign of everything. So this becomes a negative, this becomes a positive, and this becomes a negative. Very important. Then this equals, you have 3x squared, and then plus 21x, and then minus 24. From here, let's think about on this side, x squared minus 2x squared would be negative x squared. Negative 5x plus 16x is going to be plus 11x. And then you have your negative 30 there. So this equals, over here you have 3x squared plus 21x, and then minus 24. All right, so let's get this into standard form. I'm going to add x squared to both sides. So that will cancel. I'm going to subtract 11x away from each side. So that would cancel. And then I'm going to add 30 to each side. So that would cancel. So let's write this as 0. And let's say that 3x squared plus x squared would be 4x squared. And then 21x minus 11x, that's going to be plus 10x. And then negative 24 plus 30 is going to be plus 6, and this equals 0. Now I can divide everything here by 2 just to make things a little bit simpler. So this would be 2x squared, then plus 5x, then plus 3, and this equals 0. Okay, so you could solve this with factoring if you want to. I think it's probably the easiest choice here. Again, you can always use the quadratic formula if you're not comfortable. So you could say this is 2x and this is x. 3 is a prime number, so it's really 1 times 3, or you really could do negative 1 times negative 3, but everything's positive here, so I would not consider that. If you put the 3 here, it's too big. So you'd have to put the 3 here and the 1 here. So basically, this right here would be 2x, and this would be 3x, and 2x plus 3x would give me 5x. So this is good to go. So I would say that 2x plus 3 is equal to 0. And I would subtract 3 away from each side and say 2x is equal to negative 3. Divide both sides by 2. We'll say that x is equal to negative 3 halves, right? You could say negative 1.5 if you want. So that's one solution. The other one, I think we can eyeball and see it's negative 1. But for completeness, let's say x plus 1 is equal to 0. Subtract 1 away from each side. And so x could also be negative 1. So let's go back and check. So again, what is my domain before we continue? So the set of all x such that we know x can't be 0. And the other guy, x minus 5, if you set that equal to 0, we get x is equal to 5, so x also can't be 5. So this is my domain, right? The set of all x such that x is not 0 or 5. Here you got negative 3 halves, which is negative 1.5 and negative 1. So we're good to go. We didn't violate the domain. So let's just plug in and check. So we'll say 1 minus 2. And you can use the negative 1.5. I would advise that here. If you do negative 1.5 minus 3, that's negative 4.5. And if you do that multiplication, you're going to get negative 9. So this is negative 9. And this is over. You're going to have this negative 1.5. Now, if you do a negative over negative, it's a positive. So let me erase this and this. Now 9 divided by 1.5, that's going to be 6. So basically you have 1 minus 6, which is negative 5. So this is the left side, negative 5. Over here, you're going to have 3 times, let me just plug this in. So negative 1.5 plus 8. And then over here, negative 1.5 minus 1. And then over here, negative 1.5 times the quantity negative 1.5 minus 5. Okay, so negative 1.5 plus 8, that's going to be 6.5. So this is 6.5. Negative 1.5 minus 1, that's negative 2.5. So this is negative 2.5. Down here, negative 1.5 minus 5 is negative 6.5. So this is negative 6.5. Now, you can see that this guy would cancel with this guy, and you just have the negative, okay? And then basically, you have 1, 2, 3 negatives. So you might as well just say this is going to be a negative, right? And you think about 3 times 2.5, that's 7.5, and then divided by 1.5, and you're going to get 5. But again, it's 1, 2, 3 negatives involved, so you're going to have a negative 5. So this would be a negative 5. Okay, so the left and the right sides are equal, so this guy's verified. Now for negative 1, I think it's a little bit easier. So you have 1 minus, you're going to have 2 times, negative 1 minus 3 is going to be negative 4. This would be over your negative 1. So 2 times negative 4 is negative 8. So you have negative 8 divided by negative 1, which is 8. So 1 minus 8 is going to be negative 7. Now this should be equal to 3 times, you have negative 1 plus 8, that's going to be 7. Then times negative 1 minus 1, that's going to be negative 2. This is over. You have negative 1 times, you have negative 1 minus 5, which is negative 6. Can I cancel anything? Well, I can. Think about 6 divided by 2 is 3. So let's cancel this and say this is a 3, and this is gone. And then I can cancel this 3 with this 3. So essentially what I have here, again, the 3 negatives. So a negative here divided by a negative here is a positive, and then you have this negative here, which is going to change the sign. So essentially you're going to have negative 7 is equal to negative 7. So this is going to be negative 7 equals negative 7. So we get negative 1 is verified here. All right, let's take a look at problem number 10 now. So we're going to have x plus 5 over x minus 4, then plus 1 over x minus 4. This equals 7 over x squared minus 4x. Let me rewrite this. So x plus 5 over x minus 4, then plus 1 over x minus 4. This equals 7 over, I'm just going to factor this and say this is x times the quantity x minus 4. And then essentially thinking about what we have here, the LCD is just going to be this x times the quantity x minus 4, right? You have x minus 4 here and here and here, but it only occurs once in each case. And then you have this x here. So my LCD would be this guy right here. Let me do that in a different color. So this x times the quantity x minus 4. All right, so let's multiply everything by the LCD. And so I think I can write it out here. It's pretty small. So x times the quantity x minus 4. Then we basically have times this x plus 5 over this x minus 4. You could wrap this if you want. Then plus 1 over x minus 4. Then times this x times the quantity x minus 4. And this equals 7 over this x times the quantity x minus 4. Let me make this 4 a little bit better here. And this is times this x times the quantity x minus 4. So let's cancel this with this. You can have x times the quantity x plus 5. So that's x squared plus 5x. And then plus, over here, this would cancel with this. So you have x times 1, which is just x. And this equals, over here, this would cancel with this, so you just have 7. All right, so 5x plus x is going to be 6x. So this is x squared plus 6x. I could subtract 7 away from each side. So then minus 7, this equals 0. You could solve this one using factoring. It's not too bad. So this is x and this is x. Two integers that sum to 6 and have a product of negative 7. Well, that's going to be positive 7 and then negative 1. So here, you would set x plus 7 equal to 0. So x is equal to negative 7. And then also you would set x minus 1 equal to 0. So then x is positive 1. All right, so for my domain, let's put this off to the side here. It's the set of all x such that x is not equal to. If you set x minus 4 equal to 0 and solve that, you would get an x value that's equal to 4. And then also you would set x equal to 0, so that would just be 0. So it's the set of all x such that x is not equal to 4, and then also it can't be equal to 0. Now here you have negative 7 and 1, so we're not violating the domain. Now to completely check your answer and make sure you didn't make some silly mistake, you just plug in. So let's start with negative 7. So negative 7 plus 5 is negative 2. This would be over. Negative 7 minus 4 is negative 11. So this is basically 2 over 11. And then plus, if you have 1 over, you would have negative 7 minus 4. That's going to be negative 11. Let me move this up into the numerator. So basically 2 minus 1 is 1, so this would be 1 over 11. Okay, so this is 1 over 11, and this equals, over here you have 7 over. You have negative 7, then times the quantity, negative 7 minus 4. So negative 7 minus 4 is going to be negative 11. So negative times negative is positive. So let me just cancel those out, or you could actually just erase them if you want. And then basically you can cancel this 7 with this 7 and put a 1 up there. So this is 1 over 11 as well. So 1 over 11 is equal to 1 over 11. So we have verified that this is a valid solution. Okay, let's check 1. I think that'll be actually a little bit easier. So 1 plus 5 is 6 over 1 minus 4 is negative 3. So 6 divided by negative 3 is negative 2. Then plus, you have 1 over. You have 1 minus 4, which is going to be negative 3. So basically for this one, let's go ahead and say, I'll shift this up here to a minus. So I'll put this negative 2 as negative 6 over 3. And then negative 6 minus 1 is negative 7. So this is going to be negative 7 over 3. Let's set this equal to 7 over. You have 1 out here. You can just get rid of it because it's multiplication. And then 1 minus 4 is going to be negative 3. So you can move this out in front like this, and you can move this out in front. So basically negative 7 over 3 is equal to negative 7 over 3. So this one works as well. So our two valid solutions here, x equals negative 7, or x could be 1. All right, let's take a look at our practice test. We're told to solve each inequality. And for the first problem, we have x minus 7 over x minus 1, then plus 5, and this is greater than 0. All right, so the idea with this type of problem is your first step is you're going to get a single rational expression on the left-hand side. You want your inequality symbol. In this case, it's a greater than, but it could be a greater than or equal to, a less than, or a less than or equal to. And then you want 0 on the right-hand side. Okay, so what I'm going to do here is just get a common denominator, and x minus 1 would be that common denominator. So I would say x minus 7 over x minus 1. Then plus, you have your 5 multiplied by this quantity x minus 1. Make sure to use parentheses there. Then this is over. Down here, I'll just put x minus 1. No need for parentheses in that case. So we'll say this is strictly greater than 0. And from here, I'll just say this is x minus 7. Then plus, you'll have 5 times x, which is 5x. And then basically 5 times negative 1 is minus 5. This is over the common denominator of x minus 1. And then this is greater than 0. I'm going to simplify in the numerator, so x plus 5x would be 6x. Then negative 7 minus 5 is negative 12. And this is over x minus 1. So then this guy is greater than 0. All right, so once you get it to the point where there's a single rational expression on the left, and then again, you must have your inequality symbol and then 0 on the right, what you want to do is you want to set your numerator equal to 0. You want to solve that equation. And then you want to set your denominator equal to 0. You want to solve that equation. Now remember, because we're working with a rational expression, when you set your denominator equal to 0 and you solve that, that is going to give you the value or the values that must be excluded, right? Because you can't divide by 0. So that's very important. So I'm going to set 6x minus 12 equal to 0. Let's solve this equation. We'll add 12 to both sides. We'll cancel this, and we'll say 6x is equal to 12. Divide both sides of the equation by 6. We'll cancel this, and we'll go ahead and say that x is going to be equal to 2. Okay, so that's one critical value. Now, the other one is going to be x minus 1 is equal to 0. Add 1 to both sides. We'll cancel this. So we get x is equal to 1. But again, we must remember in this case that this value of 1 is going to result in division by 0, right? So if you wanted to, you can make yourself a little note and say that this is the set of all x such that x is not going to be equal to 1. So that's pretty important. You could even write out that this is going to be your domain, just to make that crystal clear. Okay, once you have all that information, you're going to go to a number line, or again, a lot of people will use a table. And then essentially, you're just going to look at x equals 1, which is right here. So let me put a little vertical line there. And then we had x equals 2. So let's put a vertical line there. And you're just splitting the number line up into regions or intervals. So let's say this is A, so that's anything that's less than 1. Let's say this is B, so that's between 1 and 2. And let's say this is C, that's anything greater than 2. So you just have to test inside of each, and then you'll consider the 1 and 2 separately. We already know that 1 has to be excluded, but we'll think about 2 separately. Okay, so let's plug in. We're going to have, and you could factor this and say this is 6 times the quantity x minus 2 over your x minus 1. Is this greater than 0? So just pick something that's in region A. And let's write this out. So A, B, and C. So in region A, I could pick 0. So if I plugged in a 0 there, 0 minus 2 would be negative 2. So you'd have 6 times negative 2, which would be negative 12. So essentially, let me write this over here. We'd have negative 12. And this would be over. You would have 0 minus 1, which is negative 1. Is this greater than 0? Well, remember, without even doing the division, a negative over a negative is positive, and a positive is always greater than 0. But you could also just say this is negative 12 over negative 1, which is positive 12. And of course, that's greater than 0. So here, this is going to be true. Now, for region B, again, just pick something between 1 and 2. I think an easy one would be maybe 1.5. But again, if you just plug that in, this guy right here, you see that if you plugged in a 1.5 and you subtract away 2, you're going to get negative 0.5, right? But just think about it this way. You'd have a negative here times a positive, so that's negative. And then down here, you'd have a positive. So negative over positive would be negative. So a negative is not going to be greater than 0. So this one is false. Okay. And just for completeness, in case you're lost, if you did 1.5 minus 2, you would get negative 0.5 or negative a half. If you multiplied by 6, you would get negative 3. And this would be over your 1.5 minus 1, which would be 0.5 or half. Let me just write 0.5 here. And negative 3 divided by 0.5 is going to be negative 6. So this would be negative 6 is greater than 0, which again is a false statement. All right, then for C, let's just pick 3. So if you plugged in a 3 there and a 3 there, 3 minus 2 is 1. 1 times 6 is 6 over 3 minus 1 would be 2. 6 divided by 2 is 3. So again, you can think about this as 3 or just the fact that it's positive. That is going to be greater than 0. So this guy is going to be true. So to put our solution together, we know that things in region A work. So anything that's less than 1, so x is less than 1, then or, we know that things in C are going to work, so anything greater than 2. But let's consider the fact that 2 and 1 are both going to be excluded. 1, because again, you would violate the domain there. X cannot be 1. We know that gives us division by 0. But for 2, remember that would result in this guy right here, this left-hand side being 0. So you're going to get 0 is greater than 0, which is a false statement. So this would be our solution. So in interval notation, we would say x is less than 1. So from negative infinity up to and excluding 1. So you have a parenthesis next to each, and it's the union with basically anything greater than 2. So you have a parenthesis next to 2, and then out to positive infinity here. Okay, so graphically, if you want to do this, you can go to your number line, and here's 1. I'm going to put a parenthesis facing to the left. Again, you can use an open circle just to show that 1 is excluded. And then I'm going to shade everything to the left here. And then I'm going to go to 2, and I'm going to put a parenthesis facing to the right. Again, you can use an open circle if you want. And I'm going to shade everything to the right. All right, let's take a look at problem number 2 now. So we have x plus 5 over x minus 4, then minus 1, and this is less than 0. So again, I want to make this left-hand side here into a single rational expression. So we have x plus 5, then over x minus 4, and then minus, we have this 1. So I'm going to multiply this by this x minus 4 over x minus 4. So you basically just have this x minus 4 up here over x minus 4 down here. And again, that's because 1 times anything is just itself. Then this is less than 0. Now you do need to be a bit careful here. You are subtracting this whole thing away. So when you set this up, go x plus 5, and then minus, I'm going to wrap this in parentheses. So this x minus 4 here, because again, the x is being subtracted away, and so is the negative 4. So that's very important. Then this is over your common denominator of x minus 4. And again, this is less than 0. We're going to have x plus 5, and then this negative is going to get distributed to each. So this is minus x, and then this is plus 4. And again, this is over this x minus 4. And this is less than 0. So x minus x is going to be 0. So essentially, you just have 5 plus 4, which is 9, over this x minus 4 here, and this is less than 0. So for these, the next step is to set the numerator equal to 0, solve that, and then set the denominator equal to 0 and solve that. In this particular case, we can't really set 9 equal to 0. That doesn't make any sense. There's no variable there. So you only have to set the denominator here, x minus 4 equal to 0. So let's say x minus 4 is equal to 0. We would add 4 to both sides and just get that x is equal to 4. Now we should note that this value of 4, if I plug that in for x, that gives me division by 0, right? So we can't divide by 0. That's undefined. So I'm just going to put a note here that my domain is the set of all x such that x is not equal to 4. So again, coming to the number line, let me put a vertical line at 4. So you're just going to have 2 regions here. So anything less than 4, let's call that A. And then anything greater than 4, let's call that B. So you have A and you have B. So just pick something in A. I would pick 0. If you plugged in a 0 here, 0 minus 4 is negative 4. So you would have 9 over negative 4. It's just a negative value, and that's always going to be less than 0. So this is going to be true. Then for B, you could pick something like, let's say 5. 5 minus 4 is 1. So you'd have basically 9 there, or a positive value, which is not going to be less than 0. So this is going to be false. Okay, so for this one, again, 4 is excluded, right? It violates the domain because we specifically said here that x can't be 4. That gives us division by 0. So for the solution, x would need to be strictly less than 4. All right, so coming back in interval notation, we'll say from negative infinity up to and excluding 4. And again, use a parenthesis next to 4 because it's excluded. And then graphically, I'm just going to put a parenthesis at 4, or again, if you want to use an open circle, that's fine. And then I'm going to shade everything to the left. All right, let's take a look at problem number 3 now. So we have x plus 6 over x minus 5. This is greater than 1. So let's write x plus 6 over x minus 5. I'm going to subtract 1 away from each side of the inequality. So you'd have minus 1 over here. And now this is greater than 0. So the idea here is to get this into one single rational expression. So what I'll do is say this is x plus 6 over x minus 5. And then minus, I'm going to multiply 1 by this x minus 5 over x minus 5, which would just give me x minus 5 over x minus 5. Then this is greater than 0. So just like in our last example, we want to make sure that we use parentheses here. So we have x plus 6 and then minus this whole quantity here. So this x minus 5, this would be over the common denominator of x minus 5, and this is greater than 0. Okay, so you're going to have x plus 6, then you'd have minus x, and then you'd have plus 5, and this is over your x minus 5, and this is greater than 0. So basically, x minus x is 0, so that's going to disappear. You just have 6 plus 5, which is 11. So we'll say this is 11 over this x minus 5, and this is greater than 0. So again, when you get something like this, you just set your denominator here equal to 0. So you say x minus 5 is equal to 0. When you solve that, you get x is equal to 5. Now, I want to note here again that your domain is going to be the set of all x such that x is not going to be 5, right? It can't be this value because if you plug a 5 in for x, you're dividing by 0, and that's undefined. So coming to the number line, let's look at 5. We'll put a little vertical line there. And essentially, I just want to test on the left side of 5 and the right side of 5. So let's call this A, anything less than 5, and let's call this B, anything greater than 5. And so for A, let's just use 0. You'd have 11 over 0 minus 5 is negative 5. So positive over negative would be negative, and that's not greater than 0. So A, this would be false, right? Nothing's going to work in A. Then for B, let's plug in 6. So you'd have 11 over, you have 6 minus 5, which is 1. So again, that would just be 11 or a positive value, and that's going to be greater than 0. So this is true. So 5 is excluded, right? Because again, that violates the domain. So we would just say that x here has to be greater than 5. So for interval notation, I'll put a parenthesis next to 5 because 5 is not included. And then we'll put this out to positive infinity. And then graphically, let me put a parenthesis at 5. And then I'm going to shade everything to the right. Again, if you want, you can use an open circle there just to show that 5 is excluded. All right, let's take a look at problem number 4. So we're going to have 5 over x minus 1. This is greater than, we have 8 over 2x plus 7. Again, the idea is to have a single rational expression on the left, and then your inequality symbol and 0 on the right. So I'm just going to subtract this guy right here away from both sides of the inequality. So I'm going to say this is 5 over x minus 1, then minus this 8 over 2x plus 7, and I'll keep my greater than symbol, and this is going to be a 0 now. Okay, from here I need to get a common denominator. So the LCD would be x minus 1, this quantity, times the quantity 2x plus 7, because there's nothing in common between those two denominators. So we'll say this is 5 over x minus 1, and this is multiplied by this 2x plus 7 over 2x plus 7. Let me wrap this, and I'll also wrap this down here. Then we have minus, you're going to have 8 over your 2x plus 7, and then times your x minus 1 over your x minus 1. So let me wrap this, and then also this. Let me slide this down just a little bit, and I'll say this is greater than 0. Okay, so over here on the left, 5 times 2x is going to be 10x, and then plus 5 times 7 is 35. Then minus, I would put this inside of parentheses or brackets or something like that so you don't make a sign mistake. 8 times x is 8x, and then minus 8 times 1 is going to be 8. Let's close that down. And instead of writing the denominator, let me just clean this up real quick, and then we'll write our denominator. So basically you would have 10x plus 35, and this minus would be distributed to each. Again, you can always put this as plus negative 1 if you're struggling with that. So this is minus 8x and then plus 8. So let me actually get rid of this line right here. And we're going to say this is 10x minus 8x, which is going to be 2x. And then 35 plus 8, that's going to be 43. And so this would be over your common denominator, which is the quantity x minus 1 times the quantity 2x plus 7. Now, I would leave this in factored form because, again, you're going to have to set this equal to 0 and solve the resulting equation. So this is easier to do versus putting it into your ax squared plus bx plus c form and then have to factor it back to solve the equation. So let's say this is greater than 0. Okay, from here, I'm going to take my numerator, which is 2x plus 43. I'm going to set that equal to 0. I'm going to solve that. So let's subtract 43 away from each side of the equation. We'll cancel this. We'll get 2x is equal to negative 43. Divide both sides of the equation by 2. We'll cancel this. And we'll say over here that x is equal to, we'll have negative 43 over 2. So that's one critical value, and this one's from the numerator. Okay, for the denominator, we're going to get 2. Okay, so we need to say x minus 1, this factor here, set that equal to 0. We would solve that and say that basically x is equal to 1, right? Just add 1 to both sides. Then the other one would be 2x plus 7 is equal to 0. Subtract 7 away from each side, cancel this. We get 2x is equal to negative 7. Divide both sides of the equation by 2, cancel this. So then also we get this negative 7 halves. Okay, it's very important to list these guys here and to keep track of the fact that these came from setting your denominator equal to 0. So we know that we can't plug in a 1 or also a negative 7/2 because we'd be dividing by 0. And again, that's undefined. So I'm just going to write this out formally. Again, if you're just doing this on your own, you don't need to. So the domain is the set of all x such that x is not equal to this 1 or this negative 7/2. Okay, so coming to the number line here, we don't have a typical number line because these values are just too big for me to put them in. But essentially, you have negative 43 over 2. That's the leftmost value on the number line. It's negative 21.5 as a decimal. So I'm just going to put that here. So negative 43 over 2 in the leftmost position. And then you would have negative 7/2. That's negative 3.5. Let's put that in the middle. And then you're going to have this positive 1. So let's put that right there. So essentially, I'm just going to test inside of each interval. So let's just say this is A. So that's anything less than negative 43 over 2. This is B. That's anything between negative 43 over 2 and negative 7/2. This is C. That's anything between negative 7/2 and 1. And this is D. That's anything greater than 1. To get some room, I'm going to get rid of these. I think we know what we have here. And we also know this is a strict inequality here. So if we think about negative 43 over 2, negative 7/2 or 1, those are all going to be excluded. Okay, so we can just determine that now. All right, so let me just write out that we have A, we have B, we have C, and we have D. And we just need a test inside, and this is going to get quite tedious. So anything less than negative 43 over 2, you could just pick negative 22. So let's check that. We'll have 2 times negative 22, then plus 43. This would be over. You're going to have negative 22 minus 1. And then you'll have this guy 2 times negative 22, then plus 7. Now, 2 times negative 22 is negative 44, and then negative 44 plus 43 is going to be negative 1. So I'm just going to erase this and put negative 1. But the key thing here is it's going to be negative. Then down here, negative 22 minus 1 is going to be negative 23. So this is negative 23. And then here, 2 times negative 22, we know that's negative 44. And if we add negative 44 plus 7, that's going to be negative 37. Now, you can go through and do the calculation for completeness, but at this point, if we're asking if this is greater than 0, we know it's going to be false, right? Because negative times negative is positive, and then you have a negative over a positive, which is negative, and a negative is not greater than 0. But just for the sake of completeness, negative 23 times negative 37, that's 851. So this ends up being negative 1 over 851, and again, that's not greater than 0. So coming back here, things in A don't work, so I'm just going to say this is false. Okay, so for B, you have between negative 43 over 2 and negative 7/2. So I'm just going to pick negative 4. So you would have 2 times negative 4 plus 43. This is over. You have negative 4 minus 1, which is negative 5. And then over here, 2 times negative 4 is negative 8. And then negative 8 plus 7 is going to be negative 1. So this up here is going to be a positive, right? I think we can see that. And down here, this is going to be a positive. So you'd have a positive over a positive, which is going to be a positive. So without going through and cranking this out, you can say this is true, right? A positive is greater than 0. But for completeness, just in case you want to see it, 2 times negative 4 is negative 8, and negative 8 plus 43, that's 35. And then negative 5 times negative 1 is 5. So this would be 35 over 5, which is 7. And of course, 7 is greater than 0. So we'll come back here and say this is true. And then for C, we have between negative 7/2 and 1. So I would just pick 0. And this is really easy to do. So this is gone. So you have positive 43 here. And let me just write that. And this is over. We'll have 0 minus 1, which is negative 1. And then 2 times 0 is 0. So you just have 7 there. And essentially, this is going to be negative, right? So essentially, you would have 43 over negative 7. That's a negative 43 over 7. That's not greater than 0. So this is going to be false. Okay, then lastly for D, you just need to pick something that's greater than 1. Let's just pick 2. So you'd have 2 times 2 plus 43 over 2 minus 1 is 1. Then times 2 times 2 is 4 plus 7 is 11. Again, without going through and cranking this out, you know this is going to be greater than 0 because you're going to have a positive over a positive, and that's always greater than 0. So let's just say this is true. In case you're curious, 2 times 2 is 4. 4 plus 43 is 47. So this would be 47 over 11. And of course, that is greater than 0. So for the solution, we know nothing in A works. In B, we're working here. So basically, x is greater than negative 43 halves and less than negative 7 halves. C, nothing works again, and then D, things work. So I'm going to put or here, x is greater than 1. Now, we already said that these critical values are all excluded because this is a strict inequality, and then also x can't be 1 and x can't be negative 7 halves because we get division by 0. Okay, looking at this, let's put this in interval notation. So I'm going to put a parenthesis, so negative 43 over 2, this is not included. And then this goes up to and does not include negative 7 halves, so another parenthesis. And the union with anything greater than 1, so a parenthesis, and then out to positive infinity. So graphically, let's put a parenthesis here, or again, you can use an open circle, and then a parenthesis here, and then I'm just going to shade everything in between, and then I'll put a parenthesis here, and then shade everything to the right. So basically, x can be anything that's greater than negative 43 over 2, which is negative 21.5, going up to and excluding negative 7 halves, which is negative 3.5, and then, or it could be any number that's greater than 1. All right, let's take a look at problem number 5 now. So we have 3 over x plus 2 is less than or equal to 4 over x minus 9. So again, I want one single rational expression on the left. I want an inequality symbol, and then I want 0 on the right. So let's say this is 3 over x plus 2. I'm going to subtract this guy away from both sides of the inequality. So minus 4 over x minus 9. This is less than or equal to 0. Okay, so let's get a common denominator going. This denominator is x plus 2. This denominator is x minus 9, so there's nothing in common. So I'm just going to say this is 3 over x plus 2, and then times this x minus 9 over x minus 9. I'm just going to wrap everything for clarity like this, and then minus, you have this 4 over x minus 9. Let me just wrap that now, and then times, you're going to have this x plus 2 over this x plus 2. Let's wrap that and wrap that. This is less than or equal to 0. Okay, so from here, I'm going to have 3 times x, which is 3x, and then minus 3 times 9 is 27. Now you have a minus sign here, so make sure you put some brackets or parentheses or whatever you want to use. You just don't want to make a sign mistake. The whole thing is being subtracted away. So you're going to have 4 times x, which is 4x, and then plus 4 times 2, which is 8. Now, I'm just going to distribute this to each, and again, you can always say this is plus negative 1 here, and distribute that like that. So this is negative 4x, and then minus 8. Let me get rid of this and drag this up here. And then basically 3x minus 4x is negative x. Negative 27 minus 8, that's going to be negative 35. Let me get rid of this. Let's put this over our denominator. Again, we're going to leave this in factored form. So x plus 2, this quantity times the quantity x minus 9. And this is less than or equal to 0. All right, at this point, I'm going to set the numerator equal to 0. So negative x minus 35 is equal to 0. We could just add x to both sides and say negative 35 is equal to x. Or you could just flip that around and say that x is equal to negative 35, like this. Let me make this 5 a little bit better. Then we want to set the denominator equal to 0. So we have x plus 2, then times this x minus 9. This is equal to 0. So x plus 2 equals 0. Here, x would be negative 2. So let's put x is equal to negative 2. And then the other one would be, you have x minus 9 is equal to 0. So there, x would be 9. So again, I want to specifically notate that x cannot be negative 2 because it would result in division by 0. And then x cannot be 9 because, again, it would result in division by 0. So these two would need to be excluded from the domain. So let's just say our domain is the set of all x such that x is not equal to negative 2 or 9. So coming back here, let's think about the critical values. You have negative 35. That's going to be the furthest to the left on this number line. Then you have negative 2. That's going to be in the middle. And then you have positive 9. Okay, you can get rid of this now. You don't need these anymore. And just keep your domain here just so you know what's going to be excluded. And then you're just going to set up some intervals. So this is A, anything less than negative 35. This is B, between negative 35 and negative 2. This is C, between negative 2 and 9. And this is D, which is greater than 9. So what I'll say here is that we have A, B, C, and D. Okay, let's test something in A. Let's test maybe negative 36. So you would have, and you have to be careful here, the negative of negative 36, then minus 35. And this would be over. You have negative 36 plus 2. That quantity times the quantity negative 36 minus 9. Is this less than or equal to 0? So the negative of negative 36 is 36. So this is 36 minus 35, which is 1. Down here, we know that this is a negative and this is a negative, and a negative times a negative is a positive. So you would have a positive over a positive, which is not less than 0 and not equal to 0. For completeness, in case you want to know, this would be negative 34, right? If you did negative 36 plus 2, that's negative 34. And then negative 36 minus 9, that's negative 45. And if you multiply these two together, you get 1,530. But again, the key thing here is that this is positive and it's not less than 0 and it's not equal to 0. So for interval A, let's just say that things are not going to work. So we'll just put false here. And then for B, let's just pick something like negative 3. So we'll have the negative of negative 3, then minus 35, and this is over. You would have negative 3 plus 2, that's going to be negative 1. And then negative 3 minus 9 is negative 12. So we know that the negative of negative 3 is 3, and that 3 minus 35 is negative 32. So we can see that this guy is going to be a negative, right? You have a negative over a positive. So what ends up happening is this will be less than 0. And again, for completeness, negative 1 times negative 12 is positive 12. And so if you had negative 32 over 12, you could divide each by 4 and say this is negative 8 over 3. So you get negative 8 over 3, which again is less than 0. So this is going to be true. Okay, for C, I would pick 0. And so the negative of 0 is 0, so you just have negative 35 in your numerator. In the denominator, you would have 0 plus 2, which is 2. And then times 0 minus 9 would be negative 9. So is this less than or equal to 0? Again, you can just see immediately this is going to be a positive because you have a negative over, this would be negative 18 down here. And essentially a negative over a negative is positive. So you have 35 over 18. That's not going to be less than 0, and it's certainly not equal to 0. So this is going to be false. All right, then for region D, we can pick 10. All right, so let's just plug in a 10 here and here and here. And we just have to be really careful. We have the negative of 10, so this is negative 10, then minus 35. This is over. This is 10 that's being plugged in. So it's 10 plus 2, that's 12. And then here, 10 minus 9 is going to be 1. So is this less than or equal to 0? Well, negative 10 minus 35, that's going to be negative 45. So this is negative 45. And this is over 12 times 1, which is just 12. Now, just looking at the sign, we know it's going to be negative, right? And a negative is always going to be less than 0, so this would be true. For the sake of completeness, if you just want to reduce this, well, negative 45 would be divisible by 3. This is basically negative 15. And 12 is divisible by 3. This is 4. So this is negative 15 over 4 if you want to calculate it. And of course, that's still less than 0. So this is a true statement. So we can say that this one is true. Okay, so let's put our solution together here. So things in B would work. So this is where x is greater than this negative 35 and less than negative 2. And then also things in D work. So I'm going to put or x is greater than 9. Now here's where we have to be really careful. Again, we have a non-strict inequality here. So the values for x that make the numerator 0, those would be included. Okay, but we still have to exclude the values for x that make the denominator 0 because that's where we're undefined. So that's why I listed the domain here. Typically, if you're doing scratch work, you don't need to go that far, but just know that negative 2 and 9 would be excluded, right? So negative 2 is going to be excluded and 9 is going to be excluded, but negative 35 is okay, right? That's the value that makes the numerator 0, right? So you'd have 0 is less than or equal to 0, which is a true statement. So I'm going to make this right here as a less than or equal to. Okay, so in interval notation, I'm going to put a bracket here next to negative 35. And this goes up to but excludes negative 2. So you want a parenthesis there because, again, negative 2 would be excluded from the domain. And then the union with anything that's greater than 9. So, again, 9 is not included. That's excluded from the domain. And this goes out to positive infinity. All right, so graphically, let me just say negative 35 is included. So you can put a bracket here facing to the right, or you can put a filled in circle if you want. That shows inclusion. And then for negative 2, that's excluded, right? So I'm going to use a parenthesis, or you could use an open circle. And I'm just going to shade everything in between there. And then for 9, that's excluded. So I'm going to use a parenthesis, or again, an open circle. And maybe let's use a different color there. That didn't show up so well. So let's put our parenthesis here again. And then I'm just going to shade everything to the right. So x here can be negative 35. That's okay. And then anything going up to and excluding negative 2. And then x could also be anything that's greater than 9. All right, let's take a look at problem number 6 now. So we have x squared plus 4x minus 21. This is over x squared minus 6x plus 9, and this is greater than 0. Okay, what I would do here, since I already have a single rational expression on the left, I have my inequality symbol, which is a greater than, and then I have 0 on the right. I would factor everything here. So this x squared plus 4x minus 21, you need two integers whose sum is 4 and whose product is negative 21. So that's going to be positive 7 and negative 3. So let's say this is x plus 7 times x minus 3. Then down here, if you wanted to factor this, you would notice that it's a perfect square trinomial. And what that means is that it can be factored into a binomial squared. So this is x minus 3, quantity squared. But what I'm going to actually do is say this is x minus 3 times x minus 3. And we're going to cancel something in a moment. So let's say this is greater than 0. Now, when you work with a rational expression, remember, before you cancel anything, you have to think about what is the domain. That domain carries over to the simplified rational expression. In this case, it's not going to matter because you have x minus 3 quantity squared. But essentially, you would want to set this x minus 3 quantity squared equal to 0. And you would want to solve this resulting equation. So this would only be true where x minus 3 is equal to 0, and that's where x is equal to 3. So let me actually write this off to the side so that we have it. I'm just going to say that the domain is going to be the set of all x such that x is not, let me slide this down just a little bit, this 3 here. Let me make that better. Okay, let me close this down. So essentially, if you plugged in a 3, either here or here, 3 minus 3 is 0. And again, you can't divide by 0, right? That's undefined. So now that I've done this, what you can do is cancel this with this. So that's out of the way. And so I'm going to rewrite this as x plus 7 over x minus 3. And this is greater than 0. Now, I just want to note, in this case, the domain didn't change between this guy and the simplified form. But if you do this, in some cases, it might change. You have to keep the domain from the original rational expression, okay? Because it carries over to the new guy that you're working with. That's very, very important. So now, what I would do is just take x plus 7 and set that equal to 0. So let's say that we have x is equal to negative 7, and I'm also going to use this x is equal to 3 here, because we need the values for x that make the numerator 0, which is negative 7, or the denominator 0, which in this case is 3. All right, so let's find negative 7. So that's going to be right there. And then let's find 3. So that's going to be right there. You can actually get rid of this at this point. This is a strict inequality. So we know that negative 7 is not going to work and 3 is not going to work. 3 violates the domain, right? Because x specifically can't be 3 because we'd have division by 0. And for negative 7 plus 7 is 0. So you'd have 0 is greater than 0. And that is a false statement. So let's set this up as region A, region B, and C. And A is anything less than negative 7. B is between negative 7 and 3. And C is greater than 3. So let's say that we have A, B, and C here. And let's just test inside of each. I'll drag this up a little bit. So for A, let's just pick negative 8. So negative 8 plus 7 is going to be negative 1. And then basically negative 8 minus 3 is going to be negative 11. But again, you could just think about the fact that a negative over a negative is a positive, and a positive is greater than 0. So this is going to be true. All right, for B, let's pick 0. So 0 plus 7 is 7, and then 0 minus 3 is negative 3, and a positive over a negative is a negative, and that's not greater than 0. So this is false. And then for C, let's just pick 4. 4 plus 7 is 11, and then 4 minus 3 is 1. So 11 over 1 is positive, and a positive is always greater than 0, so this is true. All right, so let me get rid of this, and we can get rid of this. We don't need this anymore. We know the critical values are excluded. I'm just going to say that x here is less than negative 7. Then we would say or. We'd say x is greater than 3. So let me put that here. We'll say x is greater than 3. So for interval notation, we'll have from negative infinity up to and excluding negative 7. So use a parenthesis there. And then the union with, again, 3 is excluded, so use a parenthesis there. So this goes out to positive infinity. So graphically, let me put a parenthesis here at negative 7. Again, you can also use an open circle if you want. Shade everything going to the left. And then at 3, put a parenthesis there or an open circle and shade everything to the right. So again, x can be anything that's less than negative 7, or x can be anything that's greater than 3. All right, let's take a look at problem number 7 now. So we have x squared plus 5x plus 4. This will be over x squared plus 5x plus 6, and this is less than 0. So again, we have a single rational expression on the left. We have our inequality symbol, which in this case is a less than. And then we have 0 on the right. So this is what we're looking for. So I'm going to factor this. In the numerator, I need two integers whose sum is 5 and whose product is 4. So that's going to be 4 and 1. So let's say this is x plus 4, this quantity, times the quantity x plus 1. This will be over. Down here, we need two integers whose sum is 5 and whose product is 6. So it's going to be 2 and 3. So we'll say this is x plus 2, this quantity times the quantity x plus 3. So nothing's going to cancel like we had in the last example. But again, if you were going to cancel something, if you get a problem like that, make sure you list your domain first, because that domain is going to carry over to the simplified rational expression. So that's extremely important. In this case, I can immediately just set the numerator equal to 0. So we can say x plus 4, this quantity times the quantity x plus 1. Let's set that equal to 0. And essentially, you say x plus 4 equals 0, that has a solution of x equals negative 4. And then if you say x plus 1 equals 0, that has a solution of x equals negative 1. Then for the denominator, let me actually just erase this part and keep this. So I'm going to put this x plus 2 here and this x plus 3 here. We'll say x is equal to, if you set x plus 2 equal to 0, it's x equals negative 2. And then if you put x plus 3 equal to 0, then it's x equals negative 3. Now again, I'm going to specifically list that negative 2 and negative 3, those are going to result in division by 0, so they need to be excluded from the domain. So let me put here that the domain is the set of all x such that x is not equal to this negative 2 or this negative 3. So coming to the number line, we have a lot of critical values, and they're pretty close together. So you have this negative 4 here, and then you have this negative 3 here, and then you have this negative 2 here, and then you're going to have this negative 1 here. Now you can actually get rid of this. Again, these two values up here, this negative 4 and this negative 1, those make the numerator 0. So you would get 0 is less than 0, which is false. So none of the critical values are going to work. So you can just get rid of it right now. And you can keep your domain there for clarity if you want, or you can get rid of it at this point. You really don't need it. So we'll just say that this is region A, so less than negative 4. This is B, between negative 4 and negative 3. This is C, between negative 3 and negative 2. This is D, between negative 2 and negative 1. And then this is E, which is greater than negative 1. So that is a lot of testing to do. So if you get something like this, just try to speed it up by just thinking about the sign. You don't need to plug it all the way in. I guess if you're using a calculator, it's not that big of a deal. But let's start with, I'm just going to erase this. We don't need this anymore. Let's start with negative 5 for interval A. So negative 5 plus 4 is going to be negative 1. And then negative 5 plus 1 is going to be negative 4. So this is positive 4 up here in the numerator. Down here, if you had negative 5 plus 2, that's negative 3. And then negative 5 plus 3 is going to be negative 2. So this is going to end up, you can just say this cancels with this, and you have a 2 up here. Negative times negative is positive. So basically you have 2/3 there. Okay, so this is 2/3. Now, is 2/3 less than 0? No, right? A positive is not less than 0. So this is going to be false. Okay, for B, again, this is a tight window, so it's between negative 4 and negative 3. You could just use negative 3.5. So negative 3.5 plus 4 is 0.5 or half. And then negative 3.5 plus 1, that's negative 2.5. And again, without multiplying this together, let's just say this is going to be a negative and just be done with it. So this is a negative over down here. If you have negative 3.5 plus 2, that's going to be a negative, right? That's going to be a negative 1.5. And then a negative 3.5 plus 3, that's going to be a negative 0.5. So negative times negative down here, this is a plus. So you have a minus over a plus, which is a minus. And so essentially you're going to have a negative, and that's going to be less than 0. So this is going to be true. All right, for C, you're between negative 2 and negative 3. So let's pick negative 2.5. So negative 2.5 plus 4 is going to be 1.5. And then negative 2.5 plus 1 is going to be negative 1.5. So this guy right here would be a positive times a negative, which would be a negative. And then down here, negative 2.5 plus 2 is a negative. It would be a negative 0.5. And then negative 2.5 plus 3 would be a positive, right? So negative basically over negative, which is positive. And a positive is not less than 0, so this is false. Okay, let's look at D. So now let's pick maybe negative 1.5 because it's between negative 2 and negative 1. So negative 1.5 plus 4 is going to be 2.5. And then negative 1.5 plus 1 is going to be negative 0.5. And again, you could just think about the sign here. It's going to be negative. With all these decimals, it's a little bit hard to do. Again, if you have a calculator, it's not that bad. So this is over down there. Negative 1.5 plus 2 would be 0.5. And then negative 1.5 plus 3 would be 1.5. So this right here would be a positive, right? So negative over positive is negative, and a negative is less than 0. So this would be true. Okay, for E, that's anything that's greater than negative 1. Let's just pick 0. So this would be 4. And then this would be 1, and then down here, this would be 2, and then this would be 3. So you can go through and say that this 4 would cancel with this 2, and this is 2, so basically 2/3. But essentially, you would say it's a positive, which is not less than 0, so this is false. All right, so looking at our solution here, we see that things in B work, so basically where x is greater than negative 4 and less than negative 3. We see that things also work in D, so I'm going to put OR. So in D, we have x is greater than negative 2, and we'll say and less than negative 1. Again, we know these critical values, negative 4, negative 3, negative 2, and negative 1. Those are all excluded. We talked about that earlier. So coming up here, let's say this is between negative 4 and negative 3. So again, you're going to use a parenthesis with each, and then the union. With this guy, it's between negative 2 and negative 1. Again, use a parenthesis with each. Coming to the number line, let's look for negative 4. Let's put a parenthesis there or an open circle, and then put a parenthesis on negative 3. Again, those are both excluded. Let's just shade everything in between. Let's come to negative 2. Let's put a parenthesis there or an open circle. Then come to negative 1. Put a parenthesis there or an open circle, and just shade everything in between. So x here can be anything that's greater than negative 4 going up to and excluding negative 3. Or it could also be anything larger than negative 2 going up to and excluding negative 1. All right, let's take a look at problem number 8 now. So we have 6 over x is greater than 6x minus 5. So for this one, let's write 6 over x, and then we will subtract 6x away from each side. So I'll say minus 6x. I'll add 5 to both sides, so I'll say plus 5. And then I'll say this is greater than 0. What I want to do is write this as one single rational expression on the left. So I need to get a common denominator. And essentially this denominator of x is what I'm going to use. Let me actually slide this down just a little bit. And let me erase this and move this over here. I'm going to multiply this by x over x. And I'm going to multiply this by x over x. So what we'll have is 6 minus x times 6x is 6x squared. And then plus 5 times x is 5x. Let me just reorder this and say this is negative 6x squared. And then we'll have plus 5x and then plus 6 like this. Let's get rid of this. And let's slide this up like this. And let's put this over our common denominator of x. And we'll say this is greater than 0. Okay, so for the numerator, let me just factor this. So I'm going to put a negative out in front. And then just write this as 6x squared minus 5x, and then minus 6 like this. If you wanted to factor this, let's go ahead and set up our parentheses here. Essentially, you could start with 6 and 1. So let's say we had a 6x here and an x here. And this is a minus sign, so I know in terms of absolute value, I'm going to be subtracting. And I'm trying to get to 5. Forget about the fact that it's negative 5. So for 6, it's 1 times 6, or it's 2 times 3. So if I put a 6 here, that would be 36. That's just going to be too big, right? And I can't put this 6 here because I'd have a common factor of 6, so that's out. So then you have 2 and 3. But the problem is I can't put a 2 here or a 3 here because I'd have a common factor of 2 or 3 depending on what I'm working with. So this is not going to work. You'd have to go to 2 and 3, okay? And then for 6, again, you couldn't put a 6 here or here because you'd have a common factor. So I would have to go to 2 and 3 and basically alternate. So I'd have to put a 3 here and a 2 here. And so I'd have to say that this right here would be 4x, and this right here would be 9x. So I can actually make that work if I make this guy a plus and this guy a minus, right? So essentially what you're going to have is this 4x, and then here it's minus 9x, and negative 9x plus 4x, let's say that's going to be negative 5x. So this is what I'm looking for in terms of my factorization. So let's move this back up here. And let's say this is over x, and we're greater than 0. I'm going to set the numerator equal to 0. So we have the negative of this 2x minus 3. Then this other quantity, 3x plus 2. Let's set that equal to 0. So I'm going to say that 2x minus 3 is equal to 0, or 3x plus 2 is equal to 0. Let's add 3 to both sides of the equation. We'll have 2x is equal to 3. Divide both sides by 2. So x is equal to 3 halves. So that's going to be one of these. Let me move that up into this position over here. And then the other one, let's subtract 2 away from each side. Let's cancel this. We'll have 3x is equal to negative 2. We'll divide both sides by 3. Let's cancel this. So also x could be negative 2/3. Now for the other one, we would take the denominator and set that equal to 0, solve the resulting equation. Here it's just x is equal to 0. Now, I just want to note that my domain is the set of all x such that x is not going to be equal to this 0 guy here, okay? Because again, division by 0 is undefined. Okay, so coming to the number line, let's write this as negative 2/3. Let's say this is 0, and then let's say this is 3 halves, or 1.5. So this is A, so that's less than negative 2/3. This is B, that's between negative 2/3 and 0. This is C, between 0 and 3 halves, and this is D, which is greater than 3 halves. Okay, this is a strict inequality here, so I know that this is not going to work, right? Because if you plug in a 3 halves or negative 2/3, then essentially the numerator is 0, right? The denominator is not, but the numerator is 0, so this is going to be 0 on the left side, and that's not greater than 0. So you can actually just get rid of these, and you also know that 0 is not going to work because it's going to violate the domain. So let's get rid of this. We don't need this anymore. And I'm just going to test inside of each region here. So let me write out A, B, C, and D. And we'll test inside of each. So for A, I need something that's less than negative 2/3. Let's just pick negative 1. So you have the negative of 2 times negative 1 is negative 2. And then negative 2 minus 3 is negative 5. And then here, 3 times negative 1 is negative 3. Negative 3 plus 2 is negative 1. Now you have 3 negatives. If you're just thinking about the sign, it's going to be a negative. I'm just going to write this as negative 5 just for clarity. This would be over negative 1, and negative 5 over negative 1 is 5, or you could just say it's a positive. All right, so this is 5 is greater than 0, which is going to be a true statement. All right, for B, this is a very tight window. I would just pick negative 0.5. I think that would be pretty easy to work with. So 2 times negative 0.5, that would be negative 1, and then negative 1 minus 3 would be negative 4. So you have the negative of negative 4, and then over here, 3 times negative 0.5, that's negative 1.5, and then plus 2, that's going to be 0.5 or a half. So basically, the negatives are going to cancel, right? Negative times negative is positive. 4 times a half is 2. So this is going to be 2, and this would be over your negative 0.5. Now, this is positive over negative. That's going to be a negative, and it's not greater than 0. So you can just put that this is false. If you wanted to do the division, 2 divided by negative 0.5, that's just going to be negative 4, right? So negative 4 is obviously not greater than 0. Then for C, you could pick 1. So we'd have the negative of 2 times 1 is 2, then minus 3 is negative 1. Then over here, 3 times 1 is 3, then plus 2 is 5. So basically, you get positive 5. And this is over your 1 here. So this is 5 over 1 is greater than 0, or positive is greater than 0. So this is going to be true either way you think about it. Then for D, let's just pick 2. So you'd have the negative of 2 times 2 is 4, minus 3 is going to be 1. And then over here, 3 times 2 is going to be 6. 6 plus 2 is 8. So this is going to be negative 8. So this is negative 8. And this would be over your 2. So this is negative 4, or you could just say it's a negative. So basically, a negative is not greater than 0. And obviously, negative 4 is not greater than 0. So this is false. So to put everything together and get a solution, again, we know that negative 2/3, 0, and 3 halves, they're all excluded. We talked about that already. So anything in interval A is going to work. So that's less than negative 2/3. So x is less than negative 2/3. Then or anything in C is going to work. So that's between 0 and 3 halves. So basically, I would say that x is greater than 0 and less than 3 halves. Okay, in interval notation, we'll say from negative infinity up to and excluding negative 2/3. So make sure you use a parenthesis with each. Then the union with will have anything that's between 0 and 3 halves. So I'll put a parenthesis next to 0 and then put a parenthesis next to 3 halves. They're both excluded. So coming to the number line, I want to use a parenthesis, or again, an open circle at negative 2/3. And then I'm just going to shade everything to the left. And then over here, I want to find 0, put a parenthesis there because it's not included, and then find 3/2 as well. Put a parenthesis there because it's not included. Again, you can always use an open circle to exclude something, and then I'm just going to shade everything in between. Okay, so x can be anything that is less than -2/3, or x could be anything that's greater than 0, going up to and excluding 3/2. All right, let's take a look at problem number 9 now. So we have x squared minus 4x plus 4. This is over x minus 2, and this is greater than or equal to 1. Now, normally what we do is we put a single rational expression on the left. We have our inequality. In this case, it's a greater than or equal to, and then we have 0. But instead of doing that, I want you to notice that we have a perfect square trinomial up here in our numerator. So this is going to factor into x minus 2 quantity squared, or you could say x minus 2 times x minus 2. Now, why am I doing this first? Well, you'll notice that this denominator is x minus 2. So a lot of people will just go through here and just cancel this with this. And that's fine. That's what you're supposed to do. But what you have to make sure that you do is notate the domain before you do any canceling. Okay? So in the unsimplified version of this guy, x cannot be 2. Okay, if we plug in a 2, we see we get 2 minus 2, which is 0 here. This would be 0 here, and this would be 0 here. Right? So 0 over 0 is undefined. So we need to note that. So you could say that x is not equal to 2 like that. I think that's a little bit cleaner. Or for completeness, I'm just going to list out the domain here. And we'll say that it's the set of all x such that x is not equal to 2. Okay, so let's think about it that way. Once we cancel this, we have x minus 2 is greater than or equal to 1. Now, solving this is just a basic linear inequality in one variable. I don't need to go through and test things or anything like that. I would just add 2 to both sides of the inequality, cancel this, and say x is greater than or equal to 3. Is this solution okay? Does it violate anything in the domain that I listed? No, because if I go to 3 on the number line, and I put a bracket there because it's included, and I shade everything to the right, I'm okay, right? This value of 2 is to the left of 3. Right, so there's no problems here. So if I wanted to list the solution for this problem, I would say that x is greater than or equal to 3. I could put a bracket here next to 3, and this would go out to positive infinity. Now, what I want to do is go back, and I want to flip the inequality symbol, and I want to show you how it's going to change things. And this is not on the practice test, but it's just for your information in case you want to know. So I'm going to go back, and I'm just going to cross this out and put a less than or equal to here. And let's just flip this and put a less than or equal to here. Okay. All the factoring is the same. The domain is the same. I can cancel this with this just like I did before. But what's going to happen is you're going to have a little bit of an issue. So let's say that now we have x minus 2 is less than or equal to 1. Let's take these to the number line. So if I solve this and I add 2 to both sides, this cancels, and I get x is less than or equal to 3. So there's a problem because if I look at 3, and for this one, I'm going to use a closed or filled in circle here. Normally I use a bracket, but for the sake of what we're going to do, I think it's a little bit better to do it this way. So x is less than or equal to 3. So normally I would fill that in or put a bracket and just shade everything to the left. But the problem is that x is not able to be equal to 2, right? Because in this form it's okay, but in the original rational expression that we had, it resulted in us having something that's undefined. So you actually have to erase this and put an open circle at 2. So let's do that and then do it like this. So you could write the solution here and say x is less than 2 or x is greater than 2 and less than or equal to 3. So this is how you would note your solution for this guy. 2 has to be excluded. If you wanted to put this in interval notation, you would basically say from negative infinity up to and excluding 2. So you need to use a parenthesis here next to each. And it's the union with, basically you would have 2 excluded, so you put the parenthesis there, and then this is out to 3, so you put the bracket next to 3 because it's included. So it's actually really important that you understand how to work this type of problem. This domain restriction is going to carry over. This is often a trick or trap question that you get on a test. So you know that 3 is included, and everything to the left of 3 is included except for 2, so that's why there's that open circle at 2 because it is excluded. All right, let's take a look at problem number 10. So we have x plus 6 over x squared minus 5x minus 24. And this is greater than or equal to 0. So I'm going to just write x plus 6 over here. And then down here, I'm going to factor this. So give me two integers whose sum is negative 5 and whose product is negative 24. So that's going to be negative 8 and positive 3. So x minus 8, that quantity times the quantity x plus 3. And then this is greater than or equal to 0. So again, I'm going to say that x plus 6 is equal to 0. That's for my numerator. So here, we'll just say that x is equal to -6. Again, just subtract 6 away from each side. Then for the denominator, if we set that equal to 0, well, x minus 8 would be equal to 0. So then x is equal to +8. Then x plus 3 would be set equal to 0. And then x would be equal to -3. Okay, so again, I'm just going to list the domain here, just so it's clear. So we know that x can't be 8 because 8 minus 8 would be 0. We'd be dividing by 0. That's undefined. So the set of all x such that x is not equal to 8. And then also it can't be -3 for the same reason. Okay, so for -6, that's going to be right there. And then you have -3, so that's going to be right there. And then you're going to have 8, which is right there. Okay, so this is A, so that's less than -6. This is B, between -6 and -3. This is C, between -3 and 8. And this is D, which is greater than 8. All right, so let me write that out. So A, B, C, and D. Let's put this like this. So for A, I would just pick something like maybe -7. So again, just think about the sign. So -7 plus 6 is going to be -1. So you could just put negative there, or if you want to put -1, that's fine. This would be over. You have -7 minus 8, which is -15. So this is a negative. And then -7 plus 3 is going to be -4. So this is a negative. So basically, you'd have a negative over a positive, which is negative. Now, a negative is not greater than 0. So this would be false. Okay, for B, let's use -5. So -5 plus 6 is 1. So let's say this is positive. And then for -5 minus 8, that's going to be -13. So this is negative. And then for -5 plus 3, that's going to be -2. So this is negative. So this is positive over positive, right? Negative times negative is positive. So positive over positive is positive, and a positive is greater than 0. So this is true. Okay, for C, let's pick 0. So you get 6, which is positive, over -8 times 3. So it's -24, but let's just say it's negative. Positive over negative is negative. Negative is not greater than 0. So this is false. Okay, for D, let's pick 9. 9 plus 6 is 15, so this is positive. Then 9 minus 8 is 1, so that's a positive. And then 9 plus 3 is 12, so that's a positive. So basically, positive over positive is positive, and a positive is greater than 0, so this is true. Okay, now in terms of the critical values, this guy right here, this x equals -6, again, that makes this whole thing 0, right? Because it makes the numerator 0, the denominator wouldn't be 0. So 0 divided by something that's not 0 is 0, and 0 is going to be equal to 0, right? So the or equal to, this is non-strict. So this is going to satisfy this guy. So we know that -6 would be part of the solution, but then 8 and -3 would not be. For interval B, we have from -6 up to and excluding -3. So we're going to say that x is greater than or equal to -6, again, that's included, and less than -3, again, that's excluded, because it makes the denominator here 0. Then we would say, or we can have anything that's greater than 8. So we'll say x is greater than 8, and again, that's excluded because it would make the denominator 0. Okay, so -6 is included, so I'm putting a bracket next to that, and then we're going up to and excluding -3. So you want a parenthesis with that. Then it's the union with, so it's anything larger than 8, so it's excluded, so make sure you use a parenthesis. So graphically, let me put a bracket at -6, or again, you can use a filled-in circle. Let me put a parenthesis at -3, or you can use an open circle, shade everything in between. Then at 8, let me use a parenthesis there, or again, you can use an open circle, and then just shade everything to the right. So x could be -6, or any number going up to but excluding -3, or x could be anything that is greater than 8. All right, let's take a look at our practice test. We're told to solve each word problem. So for problem number 1, we are told that a boat can go 36 miles against the current in the same amount of time that it takes to go 156 miles with the current. If the current is 5 miles per hour, how fast does the boat travel in still water? All right, so before we get into this problem, we should recognize that this is a motion word problem. So this is something where we're going to use our distance formula. So distance, which is d, is equal to the rate of speed, which is r, multiplied by the time traveled, which is t. So I'm just going to go to a little table. This is generally how we solve these. I'm going to put d for distance is equal to r for rate times t for time. Okay, now we have two scenarios. One scenario is for against. So this means we're going against the current or fighting the current. And then the other scenario is with. So that means we're going with the current, or the current is pushing on us or helping us. Now, I would start by just putting some information in that's given. It says that a boat can go 36 miles against the current in the same amount of time that it takes to go 156 miles with the current. So we are told that it's 36 miles in the scenario where we're going against and 156 miles in the scenario where we're going with. So let's put that in. So we're going to put a 36 here, under distance and with against, and then 156 here, so under distance, and then that's going to be for this with guy here. Okay, let's think about the rate and then the time. So for the rate, we are asked specifically, how fast does the boat travel in still water? So we don't know that. We are only given that the current is 5 miles per hour. So this right here is something that we're going to need to add or subtract onto the speed of the boat in still water. So because we don't know that, let's let a variable like x be equal to that. So we'll say we're going to let x be equal to this specifically. So we'll say the speed, we'll say of the boat, and this will be in still water. Okay, so what we'll do, let's come down here and say that the rate when we're going against, we have the speed of the boat in still water, which is x, and I'm fighting the current, so I need to subtract away the current, which is 5 miles per hour, so minus 5. Then for the scenario where we're going with, well, now it's pushing on me or helping me, so it's the speed of the boat in still water, which is x, and then plus 5, which is the speed of the current. So I have my distance and I have my rate, but I do not have a time. So let's go back up and let's think about this. Are we told anything specifically about the time? Well, yes, but it doesn't actually help us to model time. It says here the same amount of time. Okay, so the same amount of time. We're going to use that to set up an equation, but we can't really use that to model the time. What we have to do is take our distance formula, so distance equals rate times time, and we have to solve it for time. So basically, I would divide both sides of the equation by r. This would cancel. I'm going to flip this around and say time is equal to distance divided by rate. So using this, I'm just going to say this time here is the distance, which is 36, divided by the rate, which is x minus 5. I'm going to do the same thing here. So the time is the distance, which is 156, divided by the rate, which is x plus 5. Okay, so not too bad. Now, the key to the problem, again, let's go back up. It says the same amount of time. So that means that this boat can go 36 miles against the current in the same amount of time that it takes to go 156 miles with the current. So when I look at this, I would just set these two times equal to each other and I would solve. So I would say this is 36 over x minus 5. And we'll say this equals 156 over x plus 5. Now, this is a rational equation, but it's a very simple one. It's one where we can just solve using cross multiplication. And I would note that your domain here would specifically exclude -5 or +5, but it's really not going to come up here because this is such a simple equation. So we're going to multiply this way, and then we're going to multiply this way. So we would have 156 times the quantity x minus 5. Then we'll say this equals, we would have 36 multiplied by the quantity x plus 5. Now, you can go through and distribute and do all that stuff if you want, but I like to work with smaller numbers, and I think a lot of you do as well. So if you think about 156 and 36, they're each divisible by 12. So I'm going to divide this by 12, and I'm going to divide this by 12. 156 divided by 12 is 13, and then 36 divided by 12 is 3. Okay, so you can always multiply or divide both sides of an equation by the same non-zero number. You're not going to change the solution set, so it's perfectly legal. So over here, I would now have 13 times x, which is 13x, and then minus 13 times 5, which is 65. And this equals 3 times x, which is 3x, and then plus 3 times 5, which is 15. I'm going to subtract 3x away from each side of the equation. This will cancel. I'm going to add 65 to both sides of the equation. This would cancel. So 13x minus 3x, that's going to give me 10x. And this will be equal to 15 plus 65 is 80. Now, to finish things up, I'm going to divide both sides of the equation by 10. This would cancel, and we get x is equal to 80 divided by 10 is 8. Now, coming back up, x was the speed of the boat in still water. So that answers our question, how fast does the boat travel in still water? Well, it's going to be 8 miles per hour. So I can just put 8 miles per hour. If you want to write out a sentence, that's really up to you. Now, if you want to check this, you want to think about the time for each scenario and make sure they are equal. So let me actually erase all of this and let's think about this. In the first scenario, we're told that the boat can go 36 miles against the current. Okay, so against the current. So we know right now that the speed of the boat in still water is 8 miles per hour. The speed of the current is 5 miles per hour. So this boat, if it's going against the current, is traveling at 3 miles per hour, right? 8 minus 5 is 3. So to get the time here, again, you can do distance divided by rate. So 36 divided by 3 is going to give me 12. So that means for this scenario, they are traveling for 12 hours, right? So 12 hours at 3 miles per hour, you're going to go 36 miles. Now, what about the other guy? Well, we know that the current is 5 miles per hour, and in still water, the boat's traveling at 8 miles per hour. So 8 plus 5 is 13. So this guy's going 13 miles per hour. And 156, which is your distance, divided by 13, which is your rate, well, that's going to give you 12, so that's 12 hours as well. So we'll arrow down there and just say this is also 12 hours. So again, we know this is correct because it's the same amount of time. It's 12 hours to go 36 miles against the current, and it's 12 hours to go 156 miles with the current. So this is our correct solution. It's going to be 8 miles per hour for the speed of the boat in still water. All right, let's take a look at problem number 2 now. So we have that Heather, a traveling salesperson, first drove 1,200 miles from Alberta to Prairieville. For her second trip, she drove 975 miles from Prairieville to Atlanta. If the two trips took the same amount of time and Heather's speed on the second trip was 15 miles per hour slower than on the first trip, how fast was she driving on each trip? So in other words, how fast was she driving when she went from Alberta to Prairieville? And then how fast was she driving when she went from Prairieville to Atlanta? So first trip and second trip, let's say. So let's come down here. Again, another motion word problem. So we have distance is equal to rate of speed times time traveled. And I'm just going to go first, and then I'm going to go second. And let's just fill in the table. We'll come up here and say on the first one, it's 1,200. On the second one, it's 975. So 1,200 for the distance, and then 975. For the rate, it says just that Heather's speed on the second trip was 15 miles per hour slower than on the first trip. So let's go ahead and say that we're going to let x be equal to her speed, we'll say on the first trip. So then specifically here it says that her speed on the second trip was 15 miles per hour slower than on the first trip. So what I'll go ahead and say here is then x minus 15, because it's 15 miles per hour slower, that's going to be her speed, and that's going to be on the second trip. So coming down here, I'll put x and then x minus 15. So just like we saw in the previous example, we have where the two trips took the same amount of time. So you see it right there. The two trips took the same amount of time. Okay, so that's the key. So you want to set the two times equal to each other, but we don't have a time at this point for either one. So again, to model that, you solve the distance formula for time. And again, you get d is equal to r times t. Divide both sides by r. You get t, or time, is equal to distance divided by rate. So 1,200 is the distance divided by the rate, which is x. So 975, which is the distance, divided by x minus 15, which is the rate. Okay, so now we know the times are going to be set equal to each other. So this guy right here is going to be set equal to this guy right here. So we would have 1,200 over x is equal to 975 over x minus 15. Again, you might want to note your domain, because sometimes when you solve these types of problems, you get a quadratic and then one of the solutions may not work or make sense. But I would just say right now that x can't be 0 and x can't be 15, just to note it. So what we would say, we would cross multiply here. So we'd have x times 975, that's 975x, is equal to this x minus 15 times 1,200. So 1,200 times the quantity x minus 15. Again, if you have a calculator, it's not that big of a deal. But if you don't, you might want to divide both sides by, in this case, 75, because that would be your greatest common factor between 975 and 1,200. Again, not necessary, but it will make it easier. So this divided by this is going to be 13. So you'd have 13x is equal to. This divided by this is going to be 16. So you'd have 16x minus 16 times 15 is 240. So let's subtract 16x away from each side. We'll cancel that away. 13x minus 16x is negative 3x. And this equals negative 240. Let's divide both sides by negative 3. Let's cancel this with this and say x is equal to negative 240 divided by negative 3. That's going to be positive 80. So x is 80. So coming back up here, the speed on the first trip is 80 miles per hour. So I'm just going to put first, we'll put 80 miles per hour. And then for the second, it's going to be 15 miles per hour slower. So 65 miles per hour. All right, so to check this, I would take this distance of 1,200 and divide it by this speed, which is 80 miles per hour. So 1,200 divided by 80 is 15. So she travels for 15 hours. Now, what we need to see to verify this solution is to say, if I travel at 65 miles per hour for 15 hours, am I going to go 975 miles? Well, let's punch that into the calculator. And 15 times 65 is 975. So this is a verified solution. On the first trip, or from this Alberta to Prairieville, she was traveling at 80 miles per hour. On the second trip, where she's going from Prairieville to Atlanta, she was traveling at 65 miles per hour. All right, let's take a look at problem number 3. So we have that working alone, it takes Amanda 12 hours to cut the field. Her brother James can cut the same field in only 4 hours. How long would it take to cut the field if they work together? All right, so the idea here is that we have this rate of work problem, or we'd say work rate problem. If you're given the rate of work for each individual and you're asked to find how long it takes if they work together, then basically you think about 1 unit of time for each person. So for Amanda, in 1 unit of time, which is 1 hour, she's done 1/12 of the job. You're going to add that to the amount of the job that James can do in an hour. Takes him 4 hours. So in an hour, he's done 1/4 of the job. If we get a common denominator here, I'll multiply this by 3 over 3. This is 3 over 12 here. And then 3 over 12 plus 1 over 12 is 4 over 12, which is basically 1/3. Now, if you tell me that 2 people can work together and in an hour they've done 1/3 of the job, then I know it takes them 3 hours to complete that job. But how do we write that out mathematically? Well, I would say 1/3, which is the amount of work that's done in 1 hour when they're both working together, times x, which is the number of hours it takes to complete the job, would be equal to 1 for 1 completed job. So that's how you set up the equation. So this here, we would just basically multiply both sides by 3. So multiply by 3 over here and by 3 over here. So this would cancel and you get x is equal to 3. So essentially it would take 3 hours if they were working together. So I'm just going to say 3 hours. Now, can we check this? Of course. You would take Amanda's contribution, which is 1/12 of the job every hour for 3 hours. Now, she's going to get 1/4 of that job done, right, over the 3 hours. So she's done 1/4 of the job. Then plus, for James, he does 1/4 of the job every hour for 3 hours. So he's going to do 3/4 of that job. So if you combine what they each do, she's going to do 1/4 for Amanda, and then he's going to do 3/4 for James. So that's going to be 1/4 plus 3/4, or 1 for 1 completed job. So this is our correct answer. It would take them 3 hours if they work together. All right, let's take a look at problem number 4. So here we have working together. Jason and Peter can pressure wash a parking lot in 4 hours. When Jason works alone, it takes him 20 hours. How long does it take Peter when he works alone? So this is a variation on the original type of problem for the rate of work problem. I want you to think about if you had Jason's individual rate of work and Peter's individual rate of work, what would you do? Well, it tells me that Jason, when he works alone, it's 20 hours. So in an hour, he's done 1 over 20 of the job. Then plus, for Peter, we don't know. But if we had a certain number of hours, let's just say it was X hours, something like 15 hours or 30 hours or whatever it is, let's just say X hours. Well, then in an hour, it's 1 over whatever that is, so 1 over X. Now, when I sum these two amounts together, I get the amount of work that they both do together in an hour. Now, if I multiply that by the number of hours it takes to complete the job, which it tells us here is 4 hours, I should get 1 completed job. So there's my equation. It's not that bad. Again, if you're lost on something like this, just go through it the same way you would if you had Jason's rate of work and Peter's rate of work, and you were asked to find how long it takes when they're working together. Here, you're just trying to figure out how long it takes for Peter when he works alone. So we're going to get that as our solution here for X. So let's just distribute the 4. So you'd have 4 over 20, and then plus 4 over X, and this equals 1. So this is basically 1/5. Let's just make that simpler. And then you can just multiply everything by 5x. So multiply this by 5x. Let me slide this down here. I'll multiply this by 5x and this by 5x. And then this 5 is going to cancel with this 5. You get x plus this x is going to cancel with this x. You get 4 times 5 is going to be 20. And this equals 1 times 5x is 5x. So what we can do here is subtract 5x away from each side and then subtract 20 away from each side. We will cancel this right here and cancel this right here. X minus 5x is negative 4x, and this equals, this will be negative 20. Let's divide both sides by negative 4, and we're going to get x is equal to 5. Now, I would note here, because we were working with a rational equation, that x couldn't be 0, right? But we got x is equal to 5, so we're okay. Now, coming back, I'm just going to put 5 hours here. That was my solution for x. All right, if you want to check this, think about the fact that Jason, when he works alone, it takes him 20 hours. So let me write 1 over 20. That's what he's going to do in an hour. Now, again, if they're working together, it's 4 hours total. Okay, so times 4. What's he going to do? So 20 divided by 4 is 5. So he's going to do 1/5 of this job. Then plus, we know now for Peter, it takes him 5 hours when he works alone. So in an hour, he's done 1/5 of the job. Again, they're doing this for 4 hours when they work together. So this is 4/5. So you take Jason's contribution, he's going to do 1/5 of the job, plus Peter's contribution, he's going to do 4/5 of the job, and that's going to be one completed job. So this answer is correct here. It's going to take Peter 5 hours when he works alone. All right, let's take a look at problem 5 now. So we have that a local welding shop uses water tanks for cooling purposes. We have that the inlet pipe can fill an empty water tank in 5 hours, while the outlet pipe takes 10 hours to empty a full water tank. If both pipes are turned on at the same time, how long would it take to fill a completely empty water tank? So this one might give you a little bit of trouble, but you just need to realize that you have two competing forces. So if you had an empty water tank, then this inlet pipe could fill it in 5 hours. So in other words, in 1 hour, it's done 1/5 of that job. Then for the outlet pipe, if you had a completely full water tank, it can empty it in 10 hours. So in 1 hour, it's done 1/10 of that job. So since these guys are competing forces, you would take this guy right here, the amount that came in an hour, and subtract away this guy right here, the amount that went out in an hour, right? Because I'm trying to fill it. So this is what I'd want to figure out first. This would be the net amount of water that's coming into that tank in 1 hour. So let's say that this is times 2 over 2. So this would basically be 2 over 10. So 2 over 10 minus 1 over 10, which is 1 over 10. So in an hour, I've filled 1/10 of the tank. So we know it's going to be 10 hours. But again, officially, we would just say this is times x, and this equals 1. Multiply both sides by 10 for completeness. And we would say that x here is equal to 10, right? So it would take 10 hours. And again, if you want to check this, it's pretty simple. You would say that for the inlet pipe, again, it can fill it in 5 hours. So basically, you would say in an hour, it's done 1/5 of the job. It's going to do that every hour for 10 hours. So basically, this is going to be that it would have filled 2 water tanks, right? So this is 2. Then you have to subtract away what's been emptied, right? So this guy, it takes 10 hours to empty a full water tank. So in an hour, it's emptied 1/10 of it. And this is going to happen for 10 hours. And so 1/10 times 10 is 1. So if you look at what you get here, you get 1 full water tank, right? This is what it filled over the 10 hours. It gave you 2 of them. And this is what was emptied over the 10 hours. It was 1 of them. So 2 minus 1 gives you 1. So that's going to be 1 full water tank.